And for those who enjoy this channel and would love to support us financially, please feel free to hit that donate link. We'd greatly appreciate it. God bless.
Here's SFT.
Awesome. Thanks. We're live tonight on Standing for Truth. We got a really, really exciting discussion tonight. We've got NephilimFree here and Corp, who are going to be discussing the Genesis flood and geology and then kind of related topics. So it's going to be a lot of fun. I want to thank them both for agreeing to doing this discussion. We've also got a special guest moderator, Erica, whose YouTube channel is Gutsick Gibbon. Why don't we just go through some really brief introductions. Thanks, Erica, for being co-moderator. Thanks, Corp and Neph. If you guys want to all say a couple words.
Yeah, absolutely. I'm excited to be here. I know both of these guys. I'm very, very hyped to see what we discuss this evening. I'm just here to make sure and help things go smoothly as they can possibly go. So my name is Erica, and I'm ready for this to happen.
Me too. I'm pumped. So why don't we throw it over to Corp? Take your time. Give a brief introduction.
Well, my name's CorporalAnon. I'm a geology student who is currently halfway through to getting his bachelor's degree. And I was so kindly invited by Erica to discuss the topic of the Genesis flood and flood geology and geology in general, I suppose, with NephilimFree here. And I couldn't be happier to be here. Thank you guys for letting me come on.
Our pleasure. Our pleasure. We're really looking forward to it. Neph, over to you, brother.
I'm gonna enjoy this very much. It was good to meet. I'm gonna call him Corp. We agreed upon that, and it's a subject I like very much, and looking forward to having a nice conversation about it.
And what we're going to be doing format-wise is we're going to be really flexible. It's going to be a respectful, equally timed dialogue. Of course, we're going to start with brief opening statements. We're going to let Corp start it out. However long he takes, we'll give Neph equal time, and then we're going to jump right into a discussion. That being said, we may stick around for a short question and answer after the debate's over. So if anybody does have any specific questions, you can tag either myself or Erica. I guess for Erica, you might want to tag her under Gutsick Gibbon, I'm guessing. All righty.
Whatever works for me.
Okay, no problem. Sorry to put you on the spot while you're eating something.
It's okay. I just wasn't expecting it. I just took this big bite of bread, and I was like, oh, well.
Yeah, so just tag us with your questions. We'll do our best. We got a lot of people in the chat right now, so this is really cool. Like we said before, this is exciting. So tag us with questions. Hopefully we'll get to those. And enough from me. Let's give it over to Corp. Corp, if you do want to screen share for your opening or during the discussion, same for you, Neph, just let Praise know. He's our phenomenal tech guy. Praise, thanks for always doing it for us, brother. And Praise will make sure that he works that out for you.
Awesome. Well, in that case, since you just answered the question I was going to ask, could I get my screen shared now?
Yep. At the bottom of your screen, you should see screen or share screen, and you click that. Then you click on your desktop, whatever you have it at, your presentation. Make sure you click audio too, if you have audio.
Okay, and share audio, and it's not giving me the option to click share. Like the button's there, but it won't highlight.
Click the square within the square. There's two squares.
Oh, okay. Thank you.
Yep,
see, this is why we pay Praise the big bucks.
Awesome. So, I made a little presentation called Geology and Reality 101. This was not my title. There was a actual professional geologist who requested to remain anonymous, who actually reviewed my slides for me. So I feel a little better knowing that I've got professional back. A lot of people, when they think about geology and modern geologists, they think about uniformitarianism, and they have this idea that it's this notion that rates and processes that we see today, and only processes that we see today, have ever influenced the rock record, that catastrophe has played little to no role. And believe it or not, that view was abandoned back in the 1950s. Actually, somewhat earlier was when the trend started. There was about like a 20-year paradigm shift. We call that today Lyell uniformitarianism because it stems from Charles Lyell. Instead, we have completely embraced modern uniformitarianism, which people like myself affectionately call actualism because it represents how the Earth actually functions. Actualism, for example, allows unique processes which we do not see operating today. For example, we don't see things like the late heavy bombardment happening, we don't see flood basalts forming, and we don't see banded iron formations forming anywhere in the present today. But that doesn't stop us from making hypotheses. Again, we don't require rates of processes like erosion and sedimentation to be constant. We realized, for example, that if you've got, say, a 1 meter thick layer of sandstone, that may represent the net deposition of millions of years of erosion and sedimentation in a shallow marine area that was constantly reworked, or it could be the result of chaotic overnight deposition of sand from an ancient hurricane. Both slow and chaotic processes are completely embraced. The only things we do argue to be held unchanging are the laws of physics and chemistry, which I feel is a fairly reasonable assumption. Anything else, fair game. We rely on field data. We don't rely on dogma. And this process, this model of actualism, or this paradigm of actualism, it works. Historical geology has testable models with economic value. For example, facies modeling, wherein we use outcrops at the surface and models of geologic history and depositional environments we use these to make predictions about rocks that are deeper down that nobody's seen yet. And time again, these predictions about what rocks should be found deeper if environments were related to each other over time and happened in a certain way, these predictions come out true constantly. The petroleum industry loves these models because of how accurate they are. We use them all the time for fossil fuel and ore exploration, and it plays a crucial role in fueling our society. Because facies modeling inherently requires our understanding of a basin's depositional environment and its history to be correct in order to give accurate predictions, the fact that they are accurate upwards of 85 to 90% of the time does not make sense if all of these factors which go into them are incorrect. And I'd like to briefly go over, because I am a former Young Earth Creationist, and I would like to briefly go over the two arguments that I found most persuasive and why I eventually found out they were incorrect. For example, you often hear this claim that there's no erosion between the strata, but this just isn't true. You find erosional surfaces like buried river valleys, canyons, river channels, hills, mesas, and other things are indeed present. For example, right here, this is an actual buried landscape that is found in Eocene sediment off the coast of Iceland. And it represents more than about 100 square kilometers with over 1,000 meters of elevation. This is buried under over a kilometer of ocean sediment. And this looks like a modern landscape. That does not look like a submarine canyon. I've spoken to the author of this paper, and I asked him, could this have been a submarine canyon? And it was inconsistent with these dendritic branching patterns. You don't see these on things like Monterey Canyon off the coast of California. However, Young Earth Creationists, particularly on their websites, expect people to be able to see features such as this from miles away in very grainy photographs taken from, say, the rim of the Grand Canyon, and often on cliffs that are covered with talus and other debris, as well as plant material. And that's just not a reasonable expectation. You often have to do detailed study up close to actually notice these features. This could actually only be seen because we use seismographic imaging. This wasn't like halfway visible in an outcrop somewhere. As a good example of another one of these types of things, we're going to look at an example that's present in the Red Wall, or in the Grand Canyon's walls itself. It's called the Surprise Canyon Formation. It represents an erosional unconformity on the upper surface of the red-walled limestone and is visible in the Grand Canyon walls if you know where to look for it. And essentially what it is it's a series of dendritic paleovalleys which have been carved into the upper surface of the red wall. Over 130 miles of these paleovalleys have been mapped and more likely lie covered by sediment that the Colorado has not eroded. So we actually don't know how far it extends for. It becomes more dendritic and deeper in a east to west fashion, and the valley depths max out at about 122 meters and half a mile wide. If you'd like to see an illustration of this, this is one of the paleovalleys. This is not a flat contact. What you have here is a large paleovalley channel carved into the Redwall limestone. These are selected outcrops. There are more than these, but it was given in the Grand Canyon geology textbook to demonstrate how they branch and get deeper as you go east to west. Some interesting features of the Surprise Canyon formation is that the basal unit, which would be right down in here, actually has a thick fluvial conglomerate, which means it's a river conglomerate. You see cut and fill structures present in this basal unit consistent with modern rivers. The middle unit, in contrast, is actually estuary, and the upper unit is marine. Terrestrial fossils such as tree trunks are actually only found in that lower unit. You also find conglomerate in general of the underlying redwall limestone. What you'll find is these clasts, these broken rock fragments of the underlying stone, which can range anywhere from small pebbles that fit in your hand to entire blocks over 30 feet in diameter, bigger than cars. And the majority of these clasts are actually made of chert. Now, this is interesting. Chert is present in the redwall limestone, but it is a secondary deposit. It usually comes in little thin bands or in isolated nodules. Limestone is by far the most common mineral. However, because chert is the primary clast here, this indicates that there was time for erosion and weathering, especially chemical dissolution, to erode and abrade the weaker limestone fragments, leaving the majority of durable chert behind. In addition, the fluvial conglomerate at the bottom is found filling in caves that have collapsed in the underlying redwall. Billingsley and Buse, in their textbook on this formation, went to places where Surprise Canyon's channel fill had been found draping downward into collapse features. And what they noticed was there was no evidence of soft sediment deformation within them, which means that when you had these cave-ins happen, everything that had filled these paleo valleys had turned to stone itself. And this was all before those upper units right here got laid down. So essentially what has to happen here to get a formation like this is you need to have everything beneath the red wall laid down, of course, and then the red wall itself forms. Now the red wall has to turn to stone because you don't get a channel with stable walls like this in a bunch of soft muck. That just doesn't happen. Furthermore, you don't get giant blocks up to 30 feet in diameter of red wall if the red wall was just soft, goopy mud. It would just completely fall apart. And again, because there's no soft sediment deformation features, that means everything that filled this valley had to turn to stone too to fill in collapse features before all this up here got deposited, and then everything else throughout the geologic column. If you want some example or some illustrations of this, right here, we've got one of the fossil logs that was found growing in situ in the lower conglomerate. This was a picture of the lower conglomerate layer. All these little boulders and pebbles that are in here are from the underlying unit. This is one of those large limestone blocks from the red wall I was talking about, and these are the cave-in collapse features. So I think it's pretty easy to see that this is exactly what you would expect from a prolonged period of erosion of a lithified layer, and isn't really consistent with flat sheet erosion in the middle of the flood. In order to have this thing form in the middle of Noah's flood, you have to somehow have the red wall laid down and turned to stone rapidly. Then you have to have the channel fill deposits happen. You have to somehow get 3 distinct units, not just one basal channel fill, but it has to be 3 distinct lithologies with different fossil content. And I'm not really sure how you're expecting that to happen in the middle of Noah's flood, especially because then not only do you have to have all that happen, but now the channel fill has to itself turn to stone to fill the collapse features, and then you get everything else. These are consistent with a prolonged unconformity, but I don't see how they could happen quickly. Another argument that I really liked was this claim that you see these big folds that don't have any fractures in them. And again, this one just isn't true. What I've got here is an example of a big fold in the Tapete sandstone. Andrew Snelling loves this one. This right here is actually a picture taken by Andrew Snelling, and this is a picture of the same fold taken by the USGS Geological Survey. If we zoom in, you notice how blurry his is and how clear the USGS one was? You can see several blatant stress fractures running through this rock. In Snelling's, he puts someone in front of one of these big fractures. Why? If these cracks aren't stress fractures and they don't debunk his argument, why didn't he just take a picture of them and address them? Well, I think it's pretty obvious to see that these are stress fractures. And then you've got folds like this. This was found in southern England, What you've got here is you've got a bunch of recumbent folds, and you've got fracturing all through the middle. You've got beds breaking and cracking. You've got evidence of lithification followed by brittle deformation. And that's not the only evidence we find. With the Tapete sandstone one, I didn't have a good enough picture to show, unfortunately. You find this phenomenon called flexural slippage, where different beds inside that fold have slipped past each other. And we can experiment with soft sediment in the lab. Soft sediment doesn't do that. Only thick, solid beds of stone do that. So in many of these folds, you do find the very fractures that young Earth creationists tell us are never found. And I'm particularly concerned with the fact that Andrew Snelling is taking blurry pictures and putting people in front of the cracks. That doesn't feel right to me. That's kind of fishy. Anyways, other evidences which I found contradicted flood geology and eventually landed to me giving up the belief in such a model are things like glacial deposits from the Precambrian, the Ordovician, the Silurian, the Carboniferous. You don't get massive ice sheets in the middle of a global flood. Creationist Michael Ord likes to argue that these are merely submarine landslide deposits, but that's just not consistent with the geologic data. If you check my references, I'll scroll through them real quick and you can just pause on that and take a look at the links if you like. Dr. Kevin Henke has effectively taken Ord to task on his arguments about these ice age deposits being merely landslides. And I think they're fairly easy to refute by the presence of things like drop stones, blatant ice crystal imprints, esker and drumlin structures, which are known to be formed by glaciers, and also isotopic markers in oxygen and carbon that are only consistent with very cold temperatures. I also came to find out that there were large wildfire deposits happen. You actually find these deposits of a certain mineral called fusane, which is fossil charcoal. And there have been some wildfires, paleo wildfires, that have been noted to be bigger. They would have had to be a fire bigger than all of modern day Ireland, burning at once. That doesn't really scream a global flood, but that's the only way you can get that kind of charcoal deposit. It's found over massive areas. Other failed predictions of the flood geology models are the fact that marine reptiles and cetaceans share the same ecological environments, meaning they should have been buried at the same horizon at any given stratigraphic column, but this is observed nowhere in the world, and this doesn't just apply for them, this applies for a multitude of marine animals. And in fact, this isn't a straw man, because if any of you are familiar with geologist Ariel Roth, he's a big flood proponent, he's pretty old now. In order to address this disparity, he ended up claiming that the pre-flood world had isolated seas that were higher upland to keep the marine animals stratigraphically separated. There was no geologic evidence for these. He didn't find, say, marine deposits at different levels. Instead, he only invoked it because if that wasn't the case, you couldn't have ecological zonation at all, but that's too powerful a mechanism for the flood to just give up. And unfortunately, it doesn't work for many other fossils and correlations we see in the rock record. For example, the sorting of marine microfossils like foraminifera, as well as larger fossils like ammonites, graptolites, trilobites, and other index fossils, are simply too precise over too great a distance to be the result of chaotic depositional event, and they just don't fit flood geology sorting mechanisms. Now, I know this is a lot. I don't expect Neph to address all of it, and I would feel kind of rude if he tried to. So I do have a suggestion to any flood geologists who might watch this. Instead of arguing about things like the location of the post-flood boundary or the existence of the geologic column itself, which isn't going to help you, instead, take what you do know about Noah's flood or what you think you know, and try to come up with any model which will be useful for an oil or gas company or an ore company to find new deposits, to have predictive value. Because success in that department would give you all the funding you could want, because these companies don't care about defending deep time. They just want to make a profit. Most of the CEOs, they don't care how old the Earth is. I guarantee you could find some young Earth creationist, Texas-born, America-loving oil tycoon who will happily force dogmatic uniformitarians like myself to work for you if he thinks your model will turn a profit. And that's really all I have to say. Here are my references, if anyone would like to pause it over them and fact check me.
Awesome. Thank you, Corp, for the really good presentation. I like the visuals. It always helps. Let me see the stopwatch here. I've got about 14 minutes. So, Neph, you can take the same amount of time. And once again, any questions in the audience, just tag us, and Nep, I'll hand it over to you.
Okay. Screen share me, please. It should pull up in a second. While I'm waiting for that to show up, uniformitarian geology is not employed by the oil industry. What they look for is features of the earth, not the process that made them. They're looking for salt domes to find oil, not a process of how long it took something to form. So I don't know where you get the idea that uniformitarianism is necessary for oil formation, oil and natural gas discovery. I don't see my screen share coming up. Is it not working somehow? Let's see what's going on with that. Oh, there it is. Okay. All right. Now, you showed, speaking of the Surprise Canyon formation, you showed a screen, a picture of the bottom of the Surprise Canyon formation. And if you were to put that picture back on the screen, you'd notice something very dramatic about it. The boundary between it and the Redwall limestone is paper thin. That's not possible over uniformitarian time. It is scientifically impossible. There can be no such thing as a river.
Your thing isn't showing up.
Okay. Yeah. Maybe somebody can get me screen shared again.
Yeah, you're right. It is this black.
It was blinking back and forth. Yeah.
Okay. Don't know what's going on with that. Do you need to try to screen share me again? Should I stop screen sharing?
Yeah. Go ahead and refresh it. Yeah.
Okay.
Because we did see it for a bit, and it was just kind of twitching.
Yeah, we had it for a moment. We can just pause the time and.
Okay. Let me try screen sharing.
I'll pause it.
Okay. Now it disappeared and I can't choose it anymore.
Do you happen to have it in like a PowerPoint format?
No, it's a web page.
Okay.
Okay, so I'll stop that. That didn't work. Let me try again. I don't know what's going on. It's not pulling it up now. Oh, it's not available for screen share. Under the
Are you clicking the square within the square?
Let me see. Square within the square. I've got a list of things I can screen share here. It's pulling a drop list. And what I want to screen share is not showing up there. I don't understand why. I can try this.
I don't know. In my section, I just see mute, start can, and then can.
We're seeing it. I'm seeing something.
All right.
Problem solved, I think.
All right. Do you see now what a web page?
Yes.
I do.
Okay. So now the Surprise Canyon formation is claimed to have been something that had to have formed by long deposition. But let's consider a couple of facts. This is the length to depth ratios of rivers on the earth. The Mississippi River is 3,730 miles wide, an average depth of 61 meters. St. Lawrence, 1,200 kilometers long, 65 meters average depth. Hudson River, 507 kilometers long, 66 meters depth. Yellow River, 5,460 kilometers long, 80 meters average depth, and so on and so forth. We come down to the Surprise River Canyon formation, which is claimed to have been a river formation, river deposit. It's only 112 kilometers long, but it's 122 kilometers deep. This does not match rivers. So for this reason alone, we should have reason to believe it wasn't deposited by a river. Its length to depth ratio is way out of whack for it to be formed by a river. Now, here's some facts about this formation that call into question the claim that it was deposited by a river. It's inside the Grand Canyon. Now, the Grand Canyon strata were formed rapidly by rapid deposition. We know this because they have fine, distinct boundaries being between them. So you can't have a river flowing through sediments that take millions of years to form and have fine, distinct boundaries of them, and then have a river forming at the same time in between them. That doesn't work. It also travels at various heights through and has very through vast continuous strata. In other words, if there is massive features of strata that have perfectly fine, distinct boundaries between them, and it goes through them. So what has happened is this is an intrusion of material that took place during the flood, and it too has a fine, distinct boundary with the red wall limestone because it happened rapidly. If it were a river formation, there would be erosion and deposition at the bottom that would blend it with the red wall limestone, but there isn't. It's discontinuous and patchy, unlike a river. Its outcrops show draped folds, filled layers within the channels, not stacks of multiple channel fills, which is common in modern rivers. Drape fill is more consistent with the episode of scouring. Its various depths are anomalous. They're not consistent. It possesses marine fossils like brachiopods, corals, bryozoans, mollusks, and echinoderms. Some of these organisms do not live in rivers. Some species of these, most do not live well in a river, and some live only in the ocean. So how are you going to get those in a river? That doesn't make sense. A river is rapidly moving water, or maybe slow moving water, but it's certainly moving water, and it's not a marine environment, so to speak. So that's not a good location to be finding these creatures. Finding these fossils in this formation indicates that it was produced by the flood of Noah, not and it was never a river. Also, fossil logs have been found in it at the bottom. That's highly unlikely for a tree to sink to the bottom of a river and not decay if it's down there for hundreds of years. So how did it become a fossil unless it was buried in sediments rapidly? Now, I think this is the killer of the whole idea. Near the bottom of it, you see a conglomerate with sandstone. There's boodles and boodles of rocks that are frozen in space in the sediments. This is not what you see in the bottom of rivers. We do find gravel in the bottom of rivers, but not mixed with sandstone and not suspended. These rocks are not touching each other, most of them. And if this were deposited over a vast period of time, all the rocks would be settled to the bottom, not frozen in space in a conglomerate mix. This was thick, sluey sediments that was forced through the geologic column during the flood. It can't have been the bottom of a river because there's too much sandstone mixed with the rocks. So that just doesn't work. Now, let's look at some other evidence. I think the mountains of the earth are conclusive evidence that of the flood of Noah. The folds that we see in the strata of the earth, including mountains, demonstrates the entire mountain was soft sedimentary material when it was deformed by pressures in the earth, in the continent, that forced it upwards. Solid rock does not bend, it breaks, it's brittle. To get rock to bend, it needs to be 500 centigrade, and that's 10 to 20 miles deep inside the earth, and then uplifted as a prefab mountain. That's a preposterous idea. So what the mountains of the earth prove, because of their folded strata and their bent nature, is that they were soft sedimentary materials recently deposited by the flood of Noah, and the pressures in the continent squeezed the material horizontally and caused it to fold and to bend. Because solid rock will not bend. These right here, there is no breaks in this material. If this were solid rock and the kind of pressure necessary to bend it like that and applied to it, it would be turned into a pile of gravel. There would not be a mountain. You would have a pile of gravel. This mountain, you can see, is a profound example. It is completely bent, the whole thing. This means it was soft sedimentary material recently deposited by the flood to which pressure was applied, causing it to bend like this. One of the most profound features of this mountain is the top of it right here. This part is sheared flat. How does that happen over vast ages of time? You see the edge of it, nice and edgy. Erosion would have rounded this mountain down over millions and millions of years. The reason it's flat on the top here is because as this part of the mountain was upthrust during the flood and rose out of the waters, it ran into a stream of water moving anywhere from 80 to 200 miles per hour that literally ate the top of that mountain off. There's no other explanation for it. It can't have happened over vast time. The edge of it is too sharp. If this mountain had been exposed to the environment, changing temperatures, wind, rain, and snow for 20 million years, it would be rounded off. So it was sheared off while it was soft, moist materials. This mountain is nothing but folds. In fact, parabolic and recumbent folds. Here's a hole where there was a boulder once that fell out of the mountain while it was still soft and moist after it was uplifted. The only way that boulder would have come out of the mountain is if the material was still moist and had moisture in it. As you can see a close-up of it here. There's numerous recumbent and parabolic folds in this mountain. The entire mountain was soft, moist materials, recently deposited by the flood when it was upthrust and folded and deformed like this. This can't have happened 10 to 20 miles down inside the earth and then have it pushed up, because you'd have to remove countless trillions of tons of overburden, which means the entire landscape for miles and miles in every direction around the mountain would have to be eroded away somewhere else for the mountain to come up out of the earth. Uniformitarian mountain building is a preposterous idea. It's impossible. These mountains are the Zagros Mountains of Afghanistan. They've been folded like an accordion. And most of these folds are not broken, by the way. And the only way this can happen is if these materials were soft and moist sediments that were to which a tremendous pressure was applied to push them up and squeeze them together, just like a mud pie, and squeeze the mountain into this deformed shape. This can't happen 10 to 20 miles down inside the earth. You'd have to have miles and miles and miles. In fact, the whole range, the whole mountain range, would have been covered with 10 to 20 miles of overburden. And then that overburden would have to be eroded somewhere else for the whole mountain range to uprise from 10 to 20 kilometers down inside the earth, where the heat and pressure is great enough to cause rock to bend. That can't have happened. Another feature of this mountain is amazing. You see, the top of it has also been sheared off. How did that happen? The same way as for the other one. As this mountain rose during the flood of water, it ran into a fast-moving stream of water on the earth, in the oceans, that was moving anywhere from 80 to 200 miles per hour and literally ate the top of the mountain clean off. So now let me show you something else here. I'll go back to drop stones. I think I'll show this. I hope this is showing up. Do you see the drop stones? Anybody can tell me?
Yeah, I can see it.
Okay. This is a quartzite boulder that's entrapped inside the side of a mountain. As you can see, the strata deform around it. That's because they were soft and moist after being deposited by the flood of Noah. This huge rock that weighs probably 3 or 4 tons was transported by high velocity water and trapped in that material. It's the only explanation for it. If these strata formed over vast ages of time, they would be blended together and they would not deform around it. You can see they were soft and moist when this boulder was trapped in them, and the weight of the boulder had deformed the strata. That wouldn't happen if it were solid rock. Here's another drop stone. The strata are warped around the stone, proving that these materials were soft and moist when the drop stone was fixed in place. Another drop stone. Here's some drop stones here. You can see the distortion of this particular strata as the water was depositing it and horizontal pressure was applied to it. There's another one. And here's a drop stone, a very big one. Drop stones like this. Now, here's a parabolic recumbent fold and yet another parabolic recumbent fold. 2 of them in the same material. Notice how fine and distinct the boundaries are between them? That can't happen over geologic vast ages of time. These strata were formed by rapidly moving water, which separates materials according to density and grain size, particle size. And these folds, these parabolic recumbent folds, verify that these materials were soft like Play-Doh when this rock became fixed in place and pressure was applied. And this material over here bent and folded back on itself as it encountered the stone. As it was moving sideways and ran into the stone, it folded upon itself twice. And the weight of the stone sinking down into the moist sediments has deformed the entire features, all these strata, this whole formation. That can't happen over vast ages of time. This happens only by cataclysmic watery event. More drop stones. more drop stones. Notice how they're fixed in place. You see rock here with the material in between them. If these rocks were put in their place by vast geologic time, they would have all settled to the bottom. Instead, they're separated by bands of strata and frozen in place because these sediments were soft and moist and sluey. As the water vacated the materials, they became thicker and stiffer, leaving these stones frozen in place.
Just when you know.
Okay. There is so much more that I could show. I don't know what else to say. I'll just say this. The features of the strata of the Earth show us this. This you see here this is from, I believe, the Grand Canyon. You see how fine and distinct the boundary is between these materials? It's paper thin. You can't put a piece of paper between them. Moving water is proven in laboratory experiments numerous times. 5 to 7 papers are published every year which demonstrate this, that water sorts materials like this, exactly like you see in the photograph. What you see on the right is what we would have if these strata formed over geologic spans of time. One material would gradiate into the next. They would not have these fine bands. They would not have clear, distinct boundaries like that, because it would have to be that one material stopped being available for the environment over a period of time and another one began, and that would have happened instantly for these bands like this to form instantly. There is no such mechanism in the Earth's environment where one material is available for deposition and then no more. Now only a different material with a different color is available. That doesn't happen in uniformitarian in time. So that's my presentation.
Oh, sorry, I was muted there. Thank you so much for that presentation there, Neph. So it looks like we got the opening presentations out of the way. Both went on for roughly 14 minutes or so. So thanks to the both of you. I know those take a lot of work to do. So why don't we head into the free-flowing discussion. Erica and myself are here to make sure that it goes nice and smooth. Obviously, everybody knows Erica and myself are our positions, but we're going to remain neutral for this discussion. So unless you got anything to say, Erica, as well, we can jump right into it.
Yeah, I just wanted to note that for both presentations, we had requests in the comments for sources. So if you guys have anything that you would like to provide so others can see what you got, feel free to give them to Standing or I, and we'll make sure they get in the description.
I'd be happy to, but I don't think there's time to do that while I'm in a discussion.
Oh, no. I just meant at the end, whenever was convenient for you.
Okay.
Yeah, because they'll make it a video later.
Okay. Well, I would ask you a couple of questions in Corp. You said, let's see, erosion. You said, let me see here. You pointed to an image that was produced by seismographic images of what I would consider the antediluvian world to show that there is erosion between the strata. But the truth is, there's virtually no erosion between any of the strata throughout the whole geologic column. But you pointed to something that's under the strata as evidence of erosion between the strata. I think that's an error. And at the bottom of the surprise formation, you showed us a picture. I'd love it if you would share that picture again. At the bottom of it, you see this incredibly fine, distinct boundary between it and the Redwall limestone. If you don't mind, I'd love to see that picture again. And I can ask you, how in the world can a river, create such a fine, distinct boundary with Redwall limestone like that over a vast age of time?
Well, the reason is the Redwall limestone was lithified into solid rock beforehand, so it's not like you've got two different types of soft minerals blending together.
So then you're saying you're believing that water is not going to erode the rock?
Well, the water's going to erode the rock. That's why you have locks of the underlying Redwall in the channel fill.
And leave it with that particular shape, a teardrop shape like that?
A teardrop shape?
And conglomerate, filled with conglomerate, with rocks that are suspended?
Yes, rivers form conglomerate.
And well, rivers form conglomerate, but they're not filled with conglomerate. The strata.
No, they will fill up with conglomerate if you'll actually. Oh, I really should have had an example of the one.
Can you show me a river that has filled with conglomerate instead of that?
Sure.
Fast-moving water can make conglomerate, and with suspended stones, no doubt.
Oh, I know the exact image that I'm thinking of, and I don't know if this is the right place to look. It might actually be in one of my books. I'm sorry.
This is the image. This is the image. You see the fine distinct boundary on the left side all the way going across the bottom. This paper thin between the Surprise Formation and the Red Wall Formation.
Yes.
Okay. And it curves down like this.
Right.
Okay. What I just find is unbelievable is that a river is going to, and then look in the side of it. You see the white bands? Those are strata that are in between. See, if this was a river flow, wouldn't those strata be formed going downward at the same angle as the bottom of the formation where it meets? Why not?
Well, because first of all, are you referring to these right up here?
Yes.
These are part of the overlying supine group. They're not part of the surprise.
The top of it is flat. That one
right here.
Yeah.
This is where the overlying supine group meets the channel fill deposit.
Right.
And so so it's not associated with the same one. So I don't know how you're asking why a river would do that when we're dealing with a different unit that wasn't related to it. But another thing, can you actually screen share this time? Because I want to talk about the counterpoints you brought up. Is he gone?
What would you like me to screen share?
Yeah, please.
Go back
to your list of the problems with Surprise Canyon formation.
Okay.
I'd really like to discuss those.
Okay. Let's see if I can. There we go. Yep. Okay. Now there we go.
And if you could zoom in on them just a little bit, like the text, because I'm having a kind of a hard time seeing it in the small window.
Okay. If they'll screen share me, then praise or Erica.
Because I know you got at least yeah. Okay. I know where this is from. That list of different rivers compared to the channel fill of the Surprise Canyon Formation is by J.N. Caldwell on creation.com. I'm familiar with that article. And that's where that's from.
Only yet, no, I wrote this.
There's one right there.
There's one statement or two in here that came from that article. The rest I wrote myself.
Okay, I know they're not all from it, but I know that some of them are from it. I've seen this.
Okay, that's not an argument.
That's what I meant to get to.
Okay.
Okay. The issue with comparing the depth of a modern river, because what he's doing, where the Mississippi, for example, maxes out at about 61 meters, that is comparing the depth of the riverbed to the river surface.
To the river length.
To the river length, yes.
Yes.
The problem is you cannot compare the depth of a modern river from surface to riverbed to the depth of the Surprise Canyon, because Surprise Canyon is not a river channel. It is an incised paleo valley. What that means now, I can share my screen real quick because I have a picture to demonstrate the problem with this argument. So I don't know if you have to stop sharing yours.
Okay, I'll stop sharing.
Okay, and I'm sorry to do this, but I do have to have visual representation.
Yeah. Okay, so it's
you see,
my
is this showing up right here? Is this showing up?
Not yet.
I've got it here.
Okay. Okay. Is it there?
Yeah, it is.
Okay.
Yep.
This is part of why you cannot say, oh, well, the Mississippi is this deep, but Surprise Canyon is so much deeper, because the river never filled this whole thing to the brim. That has never been what anyone proposed. So what would be more accurate would be to somehow compare the depth of the river which flowed at the bottom, which carved down. As another example of this in real life, this would be like comparing the depth of the Mississippi to the depth of the Colorado, where it's cut down in those horseshoe bends. Are you going to tell me that the horseshoe bends weren't cut by those rivers just because the rivers aren't right now full to the top?
No,
They're an incised valley.
No, what I'm saying is it was formed by a river, allegedly, and it doesn't fit what we know about rivers. Its depth is too great and its length is too short.
Its depth isn't too great because it's not a river channel, it is a river valley.
Well,
the river channel was at the bottom.
It was claimed to be formed by a river. That's the point.
yes, a river carved the channel, but the river was never full to the channel. So
Right.
comparing it to the depth of a modern river, like surface to riverbed, is incorrect. And
No, that's exactly the point. That's the point. From the surface to the bottom of it, and to compared to the length of it, doesn't match what we know about rivers. That's
well,
the
length.
point. It's more like a canyon than it is a river.
It is it's a paleo valley.
small-
You could call it a paleo canyon, yes. But just like how the Grand Canyon is carved by a river, there was a river that was flowing through the bottom of this paleo valley system. It's not a river channel; it is a paleo valley system.
The greatest problem we have with it, though, is that it cuts right through continuous strata that cover a vast area on the Earth, thousands of square miles. Right now, all the way from the top to the bottom, these strata have fine, distinct boundaries between them, proving that they were all laid down one on top of the other in virtually no geologic time whatsoever.
So, are you agreeing?
They are because two reasons. One, they're flat. That would not be the case if they were any one of those strata were the surface of the Earth for a vast age of time. You understand the surface of the Earth gets molded and shaped by erosion over time, right?
Yeah.
Show me, okay. So all these strata are flat one on top of the other with perfectly thin boundaries between them. That can't be something that formed over vast ages of time unless you're going to tell me that entire part of the Earth experienced no erosion for millions of years. You wouldn't believe that, would you?
Well, no, because that's not what we're proposing is happening.
Well, then you have to explain how these continuous strata that encompass the entire geologic formation of the Grand Canyon, the entire area, have thousands and thousands and thousands of perfectly flat strata with fine, perfectly distinct boundaries. You have to be able to explain this to me, how any one of those could ever have been the surface of the Earth for more than 10,000 years.
Okay. First, are you conceding that it was inappropriate to compare the depth of a modern river to the depth of a paleo valley where a river was isolated to the bottom?
No, I don't. I'd like
Why?
I think I've already explained that because it doesn't fit the model for what we know about rivers. I'd like to screen share something else.
Okay.
I think I already touched upon that. Let me screen share something else if I may, please. Thank you. This you see is now these are pictures of the Grand Canyon itself. Okay. The purpose of these pictures is to show something about pediments. All right. If you see the strata here in this formation, you see these strata are part of a vast formation that stretches for thousands of square miles. They're flat. Now, for you to believe that the geologic column at the Grand Canyon formed over millions upon millions of years, you have to be willing to believe that the surface of the Earth experienced no erosion until another strata was being ever so slowly deposited upon top of it.
Well,
Then
no,
you have to be able to explain. Then you have to be able to explain how the strata are going to have a perfectly fine, distinct boundary. In many cases, the majority of strata have a very fine boundary with one another. This tells us there was no time for erosion between them. How do you explain that?
Okay, well, Surprise Canyon is one of the examples of erosion that's between them. And if you actually read the geologic literature on the Grand Canyon and the walls, there are 5 distinct unconformities where we do find substantial erosional features.
Erosion
the other boundaries are not proposed to be unconformities, which means they were sediments depositing in basins. So you're not going to see erosion at the boundaries in places where erosion has never been proposed to take place. If that makes any sense.
No, it doesn't make sense to me. Let me try to help you understand my argument really clear. I think that because it passes through strata which are continuous for thousands of square miles, which are flat and have a fine boundary between them, it has to be an intrusion, not something formed by a river over a vast period of time. The point I'm trying to make with you is this. Imagine the surface of the Earth somewhere, and 10,000 years passes. Is the surface of the Earth in that area, as far as your eye can see, going to remain smooth and flat for 10,000 years?
No.
Right.
Well, actually, it would depend on the elevation of the region. Vertical erosion does not occur in any significant amount if you're near sea level, because there's a phenomenon called base level, which restricts vertical erosion from happening. The landscape cannot cut deeper than sea level. So if you're only 100 feet above sea level for, I don't know, a 10 million year period, say you're in a tectonically stable region, you're not going to get more than 100 feet of vertical variation, because once everything that's channeling hits the ocean, it stops. It can't go deeper.
What you're appealing to is not something we're talking about. I'm talking about the entire geologic column as represented by the Grand Canyon.
Okay,
The entire mile deep of it, is flat, continuous strata which stretch for thousands of square miles in every direction from around the Grand Canyon. There's thousands of square miles of perfectly flat strata with perfectly fine, distinct boundaries between the majority of them.
What literature have you checked to get this idea that they're totally flat? Because I've read the literature, and everything I've read says they're not.
That doesn't look flat to you? Well, now when you say perfectly
what strata am I supposed to be looking at here? Because
the whole
it's rainy, so.
Okay, the whole geologic column throughout. This doesn't look. I mean, nobody says they have to be.
This is what I mean.
Nobody says they have to be perfectly flat, but they are almost perfectly flat for thousands of square miles. Look how flat that is. And that's the case no matter where you go with these particular formations of strata going all the way down into the bottom of the Grand Canyon. They're flat. Okay. And so they're in one boundary, the boundary of one strata upon the other is fine, very fine.
I don't feel okay. So if I'm understanding your argument, let me try to recite the argument to make sure that I'm understanding. You're claiming that the layers of the Grand Canyon, or the geologic column in general, but I guess we'll focus on the Grand Canyon for now, are extensive, but they're, for the most part, horizontal, and the boundaries between them are also horizontal, and they're paper thin, and you would expect there to be some sort of mixing at the boundaries.
Well, unless you think the surface of the Earth doesn't experience erosion for thousands upon thousands upon thousands upon thousands of years.
Well, here's the thing. First of all, the reason I brought up Surprise Canyon Formation is because it's an example of an erosional unconformity. And again, I have to ask, if you know that what you're dealing with is a paleo valley, that is what it's been argued to be. So it is a paleo valley, it is an incised paleo valley. A river was up here and it cut down, which creates a valley, or what you wanted to call a mini canyon, and the river is isolated to the bottom. But what Caldwell was doing was comparing an incised valley with a river at the bottom to a modern river measured from surface to riverbed. No one ever claimed the surface of that river that we carved down into the Surprise Canyon Formation was ever 400 feet deep, which is why that's an inappropriate comparison. The length is another issue because, as I stated, we don't know how far it extends. The fact is we can only see what's exposed by the erosion that's in the Grand Canyon, and they state in their textbook they don't know how far it goes.
The problem with everything you're saying is you see the bottom of the formation, how fine the boundary is between it and the materials below. It's very fine.
Can you just circle your mouse around exactly what you're talking about? Is that possible?
Yes. You see, that doesn't form over vast ages of time.
That happens because that?
Well, okay. Let me share something with you. What I've got on the screen now I'm showing you is just a tiny sampling of the many science experiments that have been performed in stratigraphy. They verify that strata form rapidly, going all the way back to 1963, 57, which show that strata form rapidly by very quickly,
it shows
by rapidly
moving water. It shows that laminations form quickly. Laminations and strata are not the same
No,
thing.
strata form rapidly because of rapidly moving water. They do not form over vast ages of time. Experiments in the laboratory have been conducted according to the United States Geological Survey, 5 to 7 papers in stratigraphy that verify these results are published every single year. So this has been done countless times in the lab, and what we get in the lab is exactly what you see in the geologic column. Strata form rapidly because of moving water. They do not form. We can reproduce what you see in the geologic column in the laboratory consistently every single time. So this verifies with observable, testable science the strata form rapidly, and that's how we got our geologic column. If it's not, then you have to be able to explain to me how boundaries this fine can happen over tens of thousands or hundreds of thousands of years. The boundary between these is paper thin. Each one of these strata would have had to have been the surface of the Earth for a very great period of time, according to your uniformitarian beliefs.
No.
I'd like to know how that's possible.
Each one of those boundaries had to be at the surface of the Earth? No, that's not what's proposed.
How did the strata become formed one upon the other then?
They're formed in depositional basins, and when you have a change in environment, the sediment that gets deposited there changes. So you'll have okay. So when you're near shore, for example, you'll have like a layer of sandstone getting laid down. And then you go further offshore, and then you have like shale, and then further out than that, you have limestone. And what happens when oceans transgress, or then when they regress, the environment that's over those particular layers changes. And so the sediment that gets laid on top of those other layers changes, which is why you get a change in sediment type.
Right, and that has to be
we're not
something.
proposing that this is above, like exposed to surface erosion.
And how long does that change take place?
It depends on the factors that are causing it. If it's caused by uplift, it could take several million years. I know that ocean sea rise, like instead of uplift, but if like say glaciers melt, that could be shorter, only a few million years instead of 10.
How long do you think it took for each one of these strata to form?
I have no idea. I don't know what locality that is.
Well,
I would say they look like shale, so they look like a deep water deposit, but I would have to actually see the relevant literature on that particular location.
So here's the purpose, the point I'm making. The fine distinct boundaries indicate that they were formed just in exactly the same manner that laboratory experiments in lamination and sediment and stratification demonstrate rapidly by moving water. That's why they have different materials, because water naturally sorts materials by density and particle size. If these materials were at the bottom of the sea and one material is available to the environment to be deposited, you have to believe that for some reason, suddenly and extremely abruptly, almost immediately, that material is no longer available for deposit, and only a different type of, or predominantly a different type of material somehow is now available and being deposited on top of the other one. And that takes place over a vast period of time. You know, chalk forms on the ocean floors, it's believed 1 to 2 centimeters per 1,000 years. That's chalk. Now, these materials may have happened a little bit faster, but that's probably not the case, according to uniformitarianism. You still have to be able to explain to me what mechanism there is in nature whereby one material is available for deposition, and then suddenly, in the blink of an eye, that material is not available anymore, and only a different one is available. That is not the kind of erosion that we know of that takes place on the Earth. How could the erosion that takes place through millions of years suddenly have changed to be one where materials erode from different areas, different types of materials, and they're mixed together to form, to cover a surface? That you're telling me that the Earth eroded in a completely different way for hundreds of millions of years until the Tertiary period. That to me makes no sense, and I'm going to put to you, you can't possibly explain it, but give it a shot.
Okay. Well, I'm having a hard time understanding what you're, okay, so I see the stratification ones. I know of these different types of experiments. These are actually very relevant to turbidite deposits, but that's not that's not like something you can equivocate with large scale strata. Now those specifically, they do kind of remind me of turbidite deposits. I don't know exactly where you got that one from, so it would make sense to see fine laminations in an area where you've got submarine landslides happening a lot. And
but then you have to say that that's what happened to the whole geologic column all over.
No, because those aren't found everywhere in the geologic column.
But everywhere we look in the geologic.
That's not what the red wall has. That's not what the Coconino sandstone has.
They have fine distinct boundaries as well.
Not like little laminations, no.
No,
unless you're talking
because
about
it's
the upper and
predominantly
lower boundaries.
No, well, of course, because it's predominantly sand, right? So, but I'm talking about the entire geologic column. The preponderance of strata in the geologic column have these incredibly fine, distinct boundaries between them, like this. And that can be produced and is produced, it's reproduced in the laboratory. But you have to believe somehow this material was available for deposition for 18,000 years, and then no more. Now only this material is available for the next 25,000 years. See, I don't see that as plausible. That to me is ridiculous. I can't imagine, and look at the boundary between these. It's unbelievable how fine and thin that boundary is. It's almost like the bottom of a styrofoam plate. So this darker material here.
I honestly can't tell if that's the difference of different sediment types or if that's just an example of a tougher outcrop.
The material has broken away because of changes in temperature and whatnot. The rock has broken and fallen away. You can see it up in here. It's darker material. It's in shadow, but nonetheless, it's a darker material. And then this material on top with paper thin boundary between them. So in your uniformitarian ideas, this material had to have been deposited over a period of possibly tens of thousands of years. And then suddenly this material, it's just not available for deposition anymore. And only the material up top. See, that's what I'm trying to explain to you about the whole geologic column, because this is the feature we find throughout the whole geologic column, including the geologic column in the Grand Canyon where this intrusion came bursting through. These boundaries,
first of all, the Surprise Canyon Formation is not an intrusion.
Well, it can't have been
features don't look like that.
Well, if it's not an intrusion, can you explain to me how in the world these materials that it passes through have these fine distinct boundaries and how it's possible to believe that one material is available for deposition only and then instantaneously that process stops, and for some reason the only material that erodes from the surface of the earth to be deposited in that location from the surface of the ocean floor or the edge of the continent, wherever you believe it was formed, only a different material now for who knows how big an area is only available a different material now.
Okay.
Can you explain the logic behind that to me?
So I'm going to go back to Surprise Canyon Formation just so there's an actual like concrete example we're talking about. Okay. So what you have happening is you've got this red wall, the red wall limestone forms. Okay. And it gets uplifted. It has to be uplifted because if it's not, no sort of stream or current is going to cut down 400 feet. So when you see a 400-foot deep channel, you know the land was uplifted at least that high. Now, during that time, and I believe the erosional period is thought to be on the order of 6 million years, you've got a river that's cutting through, and it's incising this valley. And what it's doing is it's taking all that sediment and it's moving it down. But once it starts reaching sea level, it starts to slow. And as it slows, it starts depositing its sediment. So this is why you've got clasts of the underlying red wall breaking off and ending up in this channel fill, which is a sandstone matrix. That sand, they've determined because of how mature it is, it was taken from somewhere higher up in the uplands. So it wasn't from anywhere near that area. The sand had been carried by the same river system.
For what you're saying to be true.
So hang on.
Okay.
So you were asking me, if I understand you correctly, for example, with the Surprise Canyon Formation, how did the river carve that paleo valley and then leave a distinct channel fill with a fine boundary between them, right? Is that what you're asking?
My real point is this. If the entire geologic column of the Grand Canyon was formed rapidly by moving water, which it had to be, or it could not have these flat boundaries with distinct fine boundaries between them. In other words, cannot have formed by vast geologic time. And we have something that cuts through them. We know whatever happened to cut that material through it, whether it's an intrusion or whatever, can't have taken place over millions of years because the materials that it cuts through can't be millions of years old either.
Okay, so you're saying that it can't be a river that carved over millions of years because the strata that it's cutting into do not fit a millions of years scenario.
Those strata had to be those strata had to be soft sedimentary materials for it to happen. It could not have happened to solid rock.
Okay. Looking at the example you have there, what are the lithologies there? Can you tell me? Because you're arguing for sudden random change of sediment type, and I need to know the lithologies to keep.
Well, I don't know that, and I don't need to provide that actually. All I need to do is show you that the different bands of material, the different strata, are comprised predominantly of one material or another, and that's why they have different colors.
You're looking at bedding, though.
And
you're looking at bedding, not different strata. And do you know the difference between strata and bedding?
That's, well, you're going to say that everything I should point to is bedding. And what about the Grand Canyon? Is that all bedding too? I'm just pointing out that what you see in this picture here is the same kind of thing we see throughout the entire geologic column everywhere on the continents.
It's
all over.
Not, though. They have different different appearances on different places.
Wait now. Are you telling me?
Are you arguing that, for example, that Flume experiment with the little laminations, are you basically arguing that strata are scaled up laminations?
Wait, no, not laminations. Okay, strata. I'm talking about the geologic column is largely a product of stratification. Okay, and the strata have fine distinct boundaries between them. Okay, and wait a minute. And the fine distinct boundaries and the differences in colors in the material indicate a different type of material, right? But you're
not
having
always.
To believe
you can have the same material change color based on chemical diagenesis after the fact.
That's going to be a rare thing. That's not going to explain.
How do you know it's rare?
That's not going to explain.
It's just a change. It could be anything from the change in oxygen to the change in the isotopes in the area. I mean,
that's not going to explain the preponderance of the geologic column. Are you telling me that most of these strata
changing and causing changes in color of sediment?
You're not trying to tell us that the vast majority of strata in the geologic column are comprised of nearly, if not the same material, are you?
No, but for example, with that cliffside that you have, where they look like bands of what you're calling different material, unless I know what that area is and what the lithology of that area is, for all I know, it is shale of the same type, but it's just been changed by either an alteration after it was deposited through diagenesis, or it's been caused by a very slight environmental change where it's shale, but the shale just changed color, so it's a different colored bed.
There's a difference in material in the majority of the strata. That's why they're different colors. And you have to believe
large scale, yes, that but you were showing me a picture of beds earlier. So that's
you have to believe that there is a massive change in the environment where one material is available only for deposition, and then in a blink of an eye, like instantly, in geologic time, only a different material is available for deposition. Are you under
the explanation, or are you under the impression that these strata are pure? Because they're not.
No, I'm not. But you have to be able to explain that, and you cannot. Why that would happen for every strata, virtually every strata throughout the whole geologic column.
I don't believe you've established that the entire geologic column has the pattern you're trying to suggest.
Wait, are you telling me that the preponderance of strata in the geologic column are not flat and have distinct boundaries with each other, and that there's not typically a difference in material between them?
I don't see what your problem is. First of all,
I want to know if that's
being caused by a lithified layer being covered with another sediment, so that way they don't mix at the boundaries because one's already turned to stone.
I want you to nail it down for me. We need to get this out of you. I want you to tell me if you believe that the preponderance of strata in the geologic column are different colors, not because they're predominantly a different material. Do you believe that?
There are alterations with different material. There are also places where strata has similar material that is only slightly changed. It depends on the location. You can have very thick units, or like thousands of feet of sediment, which are just alterations of like shale and limestone, and they don't leave that environment. They don't suddenly magically turn to sandstone or anything like that.
Okay, you're being very evasive. You're being very evasive.
I don't understand the question you're asking.
Well, I'll try to make it so simple that you can't be.
Okay, thank you.
Right. I think I already have. The reason for the difference in color between the vast majority of strata in the geologic column is because the strata are comprised of predominantly different materials. Nobody said they were purely silt. Nobody said they were purely shale. Nobody said they were purely sandstone. Nobody said they were purely anything, granite, not granite, but anything else. Okay. I predominantly, which is why they're continuous in color. The difference in color between the strata is because the makeup of the strata, the materials that it's comprised of, is different from the one above and below it. That is the reason that for the difference. I
think I understand now, but
do you understand that?
I would like to ask you not show pictures like this where it's bedding, where those I don't know if they're a change of sediment type or not. Instead, for example, I'd say take a picture of like the Coconino and the Hermit Shale and use that as because that would be an example of an environmental change that you're trying to tell me can't happen.
Well, I've shown you the Grand Canyon. I've shown you some.
They weren't good pictures though. Like I don't know what you're talking about.
You don't know what I'm talking about.
Like if you had a picture of say the boundary between the Coconino and the Hermit Shale.
Are you telling me
two distinct sediment types? Then I could. It would be easier to understand what you're talking about. But I think I get it.
So you're telling me you don't understand that the preponderance of strata in the geologic column have different colors materials? Because they're predominantly different materials?
I understand that thicker layers of strata, yes, are different materials, but it's just confusing when you show thinner layers of bedding and say that these thinner layers of bedding, which we don't know what the materials are because you're not telling me what they are therefore the exact same of what we see with large-scale strata boundaries.
Okay,
because
so you're saying
the geologic literature, for example, if you look at things like the divide between the Moab limestone and the red wall, they note that it's not a flat boundary. It's got relief. It's got channels carved into it. It's got blocks of the underlying wall worked into the base of the red wall limestone. These are not flat layers you don't get little blocks of underlying sediment in flume experiments. That's not what happens. It's not like a block, like a boulder of the underlying Moab is comparable to a grain from one of these flume experiments. When you have giant blocks of underlying units, that means the underlying unit was turned to rock before the upperlying units were brought in, which means you can't say the whole thing was laid down in one pulse by horizontally moving water because it requires the stuff below already be there.
Can somebody share my screen? I'll show you a different pic. What I seen is you're trying to make an exception for every picture I show you, and every picture I'm showing you, it represents the entire geologic column of the Earth.
How?
Just like this does. Okay. This is just very similar to what we find throughout the whole geologic column, no matter where we look. Boundaries, which strata, which are for the most part flat, have fine distinct boundaries with them no matter how deeply you dig into the Earth. That's what the geologic column is.
Okay.
And you seem to be trying to argue against that. And I find that to be absolutely
I'm saying
bizarre.
That your characterization of these boundaries all being flat and precise like a flume experiment is not accurate.
That's not what you're seeing on the screen?
I'm not seeing anything on the screen right now. Actually, it's just some gray image. But just because you're looking at it from far away like that doesn't compare it when you're looking up close.
Okay, are you seeing it now?
Yes.
Okay, so you're saying this doesn't represent the geologic column no matter how deep we dig. How deep we dig. The strata aren't flat. They don't have a sharp boundary with each other where one material appears to end abruptly and another material.
Others don't. There are actually an abundance of places where you don't see what you're pointing at there. And if you studied the geologic literature, you'd actually know that. You see plenty of places where, as the environment was changing, you got a shift back and forth where stuff starts interfingering.
You know how rare that is? I'm going to tell you how
not rare.
I'm going to tell you how rare it is. 1 out of 10,000 strata might be like that. That's
Do
how
you
rare
have
it is.
like a number on that? Is it like a technical citation?
No, I'm telling you because
that?
I'm telling you that because I've looked at, I don't know, thousands of photographs of the geologic column. Thousands.
You've
And
looked
what you're
at
saying,
thousands of photographs
and
from
what
a
you're
distance
saying,
where they are often stained and covered in debris,
and-
and that means that the actual up-close boundary, if you did field work, is going to look the same.
what you're telling me,
wrong.
what I'm hearing is you're denying the geomorphology of the Earth. You're denying what the geologic
No, I'm
column
not.
is in order to defend uniformitarianism, and I think that's preposterous. You're
I'm not
trying to tell
denying what
me.
it is. I'm saying I don't think you've established that's what it is.
Well, I don't
Because
know
have
where
you
in the
done like
world.
up-close field work? Do you read the technical literature of people who study places like the Grand Canyon where they see the interfingering and the changing of depositional environments up
Yeah,
close
and
that
you
you
know how
don't
rare
see
that
from
is.
far away? No, they're not rare at all. That's why you can find abundant examples in the literature.
Of a rare.
You keep
let me show you
asserting
how
it's
rare
rare,
it
but
is.
I don't know how you're saying it's rare when the
Well,
whole
see-
point is that if an outcrop is stained and has debris and plant life and other things growing on it, how you expect to see it in a blurry photograph from far away?
Blurry photograph from far away.
Yeah.
I just find this completely preposterous. What you're doing is you're denying what the geologic column is made of. If I could screen share, please, again. Let me see here. Let me see. Wait. Let me close something so I can share something. I just want to show how preposterous what you're saying is. Well, that's not working. Let me unscreen share that and then try again.
I think you're already or somebody screen shared because all I see is like.
Am I still screen sharing?
Or I'm not sure. Praise.
No, I'm not.
Because in the live stream, I don't see like the main background. I just see like us, our behind the scenes. Praise, you there?
I'm not seeing any screen
Yeah,
sharing.
there's
at
no
this
screen
moment.
sharing. There it is. I see it now.
Okay.
No.
Let me. I'm going to swap addresses in the web pages so
Yeah,
that
I'm trying to
it'll
get a
come
picture
through.
of a basin so you can see what I'm talking about here. How it's not rare. And I need to find a clear one.
All right. Let me see if this will screen share now. Yes. Okay. So this is a simple Bing search for strata. Okay. I mean, which one of these do you want to see?
Can I
How
screen
about
share?
how about that one, or
You're just showing me bedding planes, dude.
or that one? That's not a bedding plane, or that
Can
one.
I show you the
Or-
actual stratigraphy of a basin
That
so I
one.
can show you what I'm talking about? There you go. More different bedding types.
Or this.
That's what I'm talking about, Neff. Oh, look how flat it is. Look at how the boundaries are so distinct when it's covered in
And
debris.
These boundaries between them.
Again, debris from a
Flat.
distance.
And
you need to do up close
these.
actual studies.
And
That's
these.
a good example, but that's far from what the whole thing looks like.
And these.
I've got an example. Okay, well, I've got an example of a
All
basin.
right, I'm done with that. I'm done screen sharing. What you're saying is preposterous. You're denying what the geologic column looks like, no matter how deep we dig, in order to defend uniformitarianism. I find it preposterous.
There we go. That's what
Absolutely preposterous.
These are what you see when you drill. It's
I'll
not
show you.
all those flat strata. It's not all like that. You've got different interfingering like this. This is common, where you've got these different layers that intrude on each other because you've got a change of environment happening.
That's an illustration. I showed you photographs.
And this is
strata.
you know how these illustrations are drawn? They're from well cores. This is what they see when they drill down into it. This is what the majority of the geologic column looks like, and you can find all sorts of basin diagrams that look exactly like this.
I showed you with photographs what the preponderance of the geologic column looks like from various locations across the
You've
globe.
shown me different variations of bedding planes and some large-scale strata that are covered in debris.
So they're covered
And
in debris because
maybe
they're
some deep
exposed.
water deposits, yes, but if
Okay, they're going to be exposed. There's going to be debris on them. But that's not explaining the geologic column, though. The
whole
geologic
point is that
column.
when you get up close, when you have to actually get up there and do the dirty work and look at the debris, it's not all flat little bedding planes like you see in those little flume experiments with laminations. It's not just those things blown up. That's not what we observe.
That's not.
No, it's not.
Okay, that's bizarre. I truly find that to be. I'm just.
You can do any sort of literacy.
I'm going to. The literature doesn't agree with you.
It doesn't.
No, sir. This is what the geologic column looks like. They're going down as deep as you can get. And that's what every scientist on this planet who works in geology, sedimentology, hydrology understands. And what you're saying is not true.
Why do the depositional basin examples look different from that?
What
some
you're saying,
of them look like that, yes. But you're saying everywhere on the planet.
Yeah, what you're saying is not supported by any geologist. I can't possibly understand that. Look, this is where man has cut through it. It's the same. The strata, you can see faults here, but you see how the strata are continuous and they have a flat boundary between them. And that's the case with the entire geologic column.
I know that you have different strata that have flat boundaries between them. I'm not denying those exist, but maybe I'm mishearing you, but it sounds like you're saying, for example, the no interfingering, there's no intermingling of it. See, that would be a better example. Is that what you're talking about too?
I'm talking about everywhere on the Earth going down 1,800 meters, average of 1,800 meters deep. Paul Nelson.
It's hard for me to understand you. So
Paul Nelson at the Tulane University publishes on geology, and he states the continents are covered with 1,800 meters of sedimentary strata.
Okay.
All right, that's the whole geologic column, and what the geologic column
looks like. The problem is not. I know that some of them. No, Nephilim, it doesn't. No. There are tons of places. Yes, you can see lots of places where that stuff exists, but there are other places where you have unconformities, where you have paleo valleys, where you have carved-in river channels. You can see buried hills and mesas and all sorts of things. It's not just flat bedding plains everywhere.
These are not all bedding plains. What you're doing is you're denying you're denying that the preponderance of the geologic column has continuous strata, which are typically flat or flattish and have fine boundaries between them in order to defend uniformitarianism. Well, and what you're doing is pointing to the rare exception to that, because there are plenty of exceptions. You're pointing to the rare exception and attempting to say that this is what represents the geologic column, in order to defend against the fact that you cannot explain how these materials could vary, or what kind of mechanism there is in nature that provides one material and then abruptly stops, and only a different material, or which
you don't think there's mechanisms that
is available for deposition. And to defend against your inability to explain that, you're trying to you're putting forth an absurd and false idea, which is not supported by geologists. That is, that the geologic column is not as I described it. And
if I may intervene quite briefly, Nephi, maybe it would help if we give you just a minute or so to phrase your question as clearly as you can.
Because I genuinely think I've kind of got what you're saying, but it's hard for me to grasp the exactness of your arguments. If you could please rephrase it one more time.
Sure, I don't see how it's hard to understand. I'll say it again. The strata of the Earth going through the geologic column from Cambrian to the top are comprised largely of continuous strata, which are predominantly flat and have fine boundaries between them.
Which would make sense because you know where the majority of these sediments are found, right? They're found in depositional basins.
And the problem you have
tend to be flat.
The problem you have is explaining the boundary between them with uniformity and time, which you can never do.
Depositional basins tend to be very flat. So the flatness of the strata I don't see how that's a problem.
Everywhere is a basin.
Unless you're dealing No, but where you've got an outcrop, you've got a basin's deposits which have been exposed. Sediments only accumulate in basins, so you're looking at where a basin used to be when you're dealing with a sedimentary deposit.
I disagree. Basins, sediments don't only form in basins. The entire geologic column was created by the Noahic flood in less than a year and a half.
Okay,
I don't know.
But depositional basins would still exist in the middle of Noah's flood. That's the point. If you actually look at flood models that people make, they still have depositional basins where there has been flood-induced subsidence.
The vast majority of the geologic column isn't basins. You're misrepresenting the geologic column to defend
the vast majority of the geologic column isn't basins. No, they are preserved things that used to be within basins. Basins shift over time.
What you're trying to do is avoid answering the question.
I don't see what your question is. Are you saying that the whole geologic column at once would have to be a depositional basin to look like this?
No, I've said it clearly. You're attempting to make it look like you can't understand my clearest question. The question is, as I've put it forth about 6 times now, that because of the features of the geologic column, the strata, the individual strata, have distinct boundaries between each other. In many cases, it's paper thin. In other cases, it's a bit less than paper thin, but nonetheless, it's very fine. Now, the question for you is, how in the world is it plausible to believe that there is a recurrent mechanism in nature that happens over and over and over and over and over and over and over, thousands and thousands of times throughout geologic history, whereby one material is available from the environment that even over a vast area of time, of land, even possibly thousands of square miles, such as the case with the Zuni and the Kaskaskian and other mega sequences. Even if you put it down on a smaller scale of only 100 square miles, much less 10,000 square miles, these continuous strata have fine, distinct boundaries one to the other, comprised each one above the other, predominantly of a different material, which is why they're of a different color. Now, you can't explain with uniformitarianism how it's plausible to believe that there is a recurrent mechanism in nature where over a vast area of land, vast, hundreds of thousands of square miles, one material
Do you not know
is
what a continental shelf is?
Let me finish, I'm almost done. Where one material is predominantly available for deposition and then abruptly no more. And then only predominantly a different material is available for deposition, and this happens over and 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 over.
Okay.
You can never explain that.
Okay. Can I talk now?
Do you understand the problem?
Yes, I believe I understand your question. Yes.
Okay. Good.
Okay. First of all, some of the biggest depositional basins in the world do cover hundreds of thousands of square kilometers. They're found on the continental shelves. The one off the coast of Siberia is a great example. These tend to be relatively flat areas, which is what, and because the vast majority, over I believe 95% of the geologic record is from shallow marine environments, meaning they are from continental shelves, that would explain why they are flat and often can get to such large scales. But other examples, those mega sequences you're talking about, in geology we actually call them cratonic sequences, those are caused by sea level transgressions. And if you read the literature on them, what they note, and this is why creationists actually have a problem with mega sequences, or some of them do at least, is because what you have happening is the sea level will rise, so the environment shifts, which is what causes the change in sediment type. A change in environment leads to a change of sediment type. But then what happens is it'll come back some, and it'll interfinger with itself, and it'll come up. And if you actually read the literature on this, it's not all perfect bands. What you'll have is it'll pinch out because in different areas the water didn't get as deep or as shallow. And so the earlier type of sediment stayed being deposited there. And it's a lot more, and that's why I gave the example of the Permian Basin, because that's what it actually looks like when you look at it on a large scale. You'll see that different things pinch out and pinch in because there's a change of environment going on, even at the same time. So the fact that you're giving me, I understand the point of you showing me those like outcrops where it's those little bands constantly of altering material. I get what you're trying to say, but what I'm telling you is that when you look on a large scale, you've got different examples of these things happening, yes, but they're not continuous. It's not just one continuous banding. In any large enough area, you'll see that it'll pinch out in different areas because of a lateral change in environment. And so so further away from that, once it pinches out, you've got a different type of material forming.
That does nothing against the flood. Nothing. That's perfectly explainable by the flood.
Sure.
But
what you sure. If you want to argue, if you want to say it's arguable or it's compatible with the flood, sure. But
okay. But what you're saying, though, what you're trying to tell, what sounds like you're trying to convince me is that it's true that throughout geologic time, there is a mechanism in nature that one material is predominantly available, and then for some reason it no more is, and only a different one over a vast area of land.
Well, if the area is experiencing
can you
gentle
explain that to me?
If the area is experiencing, for example, gentle sedimentation, so where the sedimentation rate isn't that great, then an environmental change on the course of 100 years won't actually mean that much in terms of laying down a different material. And so it will look with maybe and you can actually, when you get up close, this is what I was talking about, when you get real up close there, you can see how it mixed before changing to a different material, but you have to be way up close, sometimes looking with like right up to your eye to actually see the thin band, because if the sedimentation was slow enough, you won't really see that change from any sort of distance. But it does exist out there. And the mechanism for it is that as environments change, the sediment type that's getting laid down there changes as well. Alternatively, if the environment doesn't change, there is another mechanism that's related to the host sediment. So for example, if let's say over 20 million years, for example, you're getting, 800 feet of strata, and it's for the most part sandstone. And that sand that's coming down, that's being brought by the rivers to that delta, or whatever we're dealing with, is coming from a mountain. When that erosion from the uplands eventually hits a sediment of a different type, it hits another rock, like for example, starts hitting shale or mud, that's going to change what's being brought down too.
Well, I understand all that.
The host sediment can change, and so can the environment, and that's what causes a change in material.
I understand that, but what you're trying to tell me is this occurs consistently, time after time, over vast areas, thousands of square miles in area.
Environmental changes will happen.
You're saying
I do not know of any areas that are hundreds of thousands of square miles where it is the same laminations for that whole distance. I don't know of a relevant basin that exists like that, and I need to see one to say that exists.
The state of California has more than 1 million square miles in it. I've talked about mega sequences, and the Grand Canyon covers area of more than 1 million square miles. Okay, so I'm not sure if you understand square miles, but that's really how big that is. But what you are confessing to is that you believe that one material can be predominantly available for deposition over a vast area of the Earth, and then suddenly no more. And then
there's an environmental change, especially with a sea level rise or fall.
And then a material of the Earth, where that material came from, is now predominantly a different material. So that when erosion brings it over to there,
changes too. Yes.
So then a different material, only a different material. What you're trying to tell me is there's a geologic column just like the one we have somewhere else that is eroding and creating the other one. It's the most absurd thing.
There are areas where you've got several hundred feet of sedimentary strata that are uplifted, aren't experiencing deposition anymore. And as they're eroded, that's where the sediment's coming from. The column is destroyed partially in one place, and that sediment gets brought down and redeposited somewhere else, usually at rivers of the continental shelf.
Let's make really clear the preposterousness of what you're saying is.
How is that preposterous?
Let's imagine,
it seems pretty common sense.
I'm going to make it really clear for you. We have an area that's 10,000 square miles in area, okay? That's not as big as you think, okay? 1,000 miles in each direction. Okay, let's make it really small. 500 miles. 500, 500 miles, 5,000 square miles. Let's make it 5,000, okay? Now, the strata are continuous in that area, as we see in the geologic column, Okay, one distinct material ends abruptly. Another strata with predominantly a different material is paper thin
Representing a change of
right on
depositional
top of it,
environment or host
and this
rock.
goes
Yes.
on and on up through the geologic column. All right,
Okay.
a huge area of land. Okay, now where did those materials come from to cover that vast area of land? They came from somewhere else, right?
It came from rock in the highlands.
Right. Okay. So what you're telling me is that the materials over there are eroded and washed way over here to cover that area, and then for some reason that area no longer has any more of that material, and there's no material going to mix in coming in from this side or from this area or that direction over there.
Well, they do mix in, and that's why you see pinching in and out.
It's only coming from that other area over there where all this material is available. And now, for some reason, it's not that material anymore. It's just a different one that's available. And it comes over and fills that area too. And it's not mixed in with stuff from the left and the north and the south and the east at all.
Can I edit the example?
I'm going to end my discussion of that. I'm just going to put it forth. What you're believing is absolute nonsense.
That changes in environment cause different source sediments to start being deposited elsewhere.
To believe it happens the way you're stuck with having to believe it to try to explain the geologic column is absolutely preposterous.
That's an argument from personal incredulity.
No, it cannot be true. Well, I think the reasoning behind what I put forth makes that clear. You're telling me
I think the reasoning I put forth is easy to understand. You have sedimentary strata that gets laid down in a basin, and then it gets uplifted to be a mountain somewhere or whatever, a plateau. And now that sediment is being carried by things like rivers and wind. You realize that there is, and don't say that's too far so it's ridiculous. Sediment from the Rocky Mountains, observable today, gets brought down to the Gulf of Mexico by the Mississippi River Basin.
What you're essentially telling us is there's an upside down version of the geologic column that we have over here, right over there, miles and miles away. And as it erodes, yes, think about it. As that one at the bottom on the left fills in, came from material on the right. Okay, and then more material comes, and more material comes, and more material comes, and to move every time from the left to the right, whatever you're depositing is on the left, you're depositing on the right. You're tearing it down from the right on the right to build it up on the left. That means you have to believe also another absurdity is the geologic column is upside down on the right to make the one on the left. It's just the most bizarre.
No, that's just host rock. It's just source rock. I mean, it's not like we have.
That's what I mean. The geologic column is upside down.
It's not like we have, say, an area of like 500 by 500 with like, I don't know, trilobites. And are you saying that I'm suggesting that the area in the mountains where this sediment that's being deposited in that area is being brought from also has those trilobites just in reverse order? And that it's brought down?
Of course not, but that's another absurdity of what you're believing.
That's not anything of what I'm believing, and that's not what I'm proposing.
I think I've made my case.
To the area, dude.
I think I've made my case. There's no way you can explain.
Somewhere else.
There's no way you can explain the distinct boundaries with the predominantly different materials of the
changes of environment, dude. That happens. And
well, I know we've been through all that, and it leads you down the road of complete absurdity. Could you share my screen with me? Someone share my screen. Have something.
Do you want to end it here then? Or?
Well, I'd like to show you something else and get your response about it. If I could.
All right.
All right. Here's some couple of things I'd like you to respond to. This is called a planation surface. There's many of them on the Earth. Huge areas, thousands and hundreds of square miles in area, sometimes thousands or tens of thousands of square miles in area. I'm going to put it forth to you that the reason we have in the middle of nowhere a gigantic flat area is because during the end stage of the Noahic flood, as the water flowed off the continents in sheets, moving at high speed, it literally sheared that whole place on the Earth flat. There's the geologic column. This is Sheep Mountain. Sheep Mountain is in, I believe, I've forgotten what state it's in. But as you can see, the curvature of the materials around it demonstrate that the pressure in the continent as it was moving horizontally squeezed that mountain up out of the Earth.
No, they don't. Okay, first of all, from this distance right here, you're not going to see stress fractures of what I was talking about
I didn't
earlier.
say anything about fractures. I'm pointing out that the deformity of the landmass that surrounds this mountain is the reason the mountain uplifted. Now, every geologist in the world agrees with me on this. Okay, that's why Sheep Mountain formed. That's why mountains uplift, because of horizontal pressure in the continents, right?
And also from stuff from beneath.
Okay,
it's not just horizontal.
Well, when we see this kind of deformity, we know that the horizontal movement.
I don't know, dude. It kind of looks like. From
You're saying
it might just be me. I don't know about the area. I don't know about Sheep Mountain. I've never studied it. I don't know what the literature says about it. But it kind of looks like to me that may have been where other parts of the mountain were and have been eroded down. I'm not sure, but they share a very similar shape, and that might be a mountain route. I'd have to check the literature on it before I could say that your sequence of events is actually what occurred. And the fact that you don't have a technical citation that's explaining that that's what occurred doesn't help. Oh, he's cutting out.
Hold on a second, Nephi. We can't hear you too well.
You're cutting out a lot.
No problem. Let me jump in real quick. Daph, you're starting to sound like a robot real quick. Maybe just check your audio or something. Neph, I can see you like going through your slides, but we don't hear your voice. So if you wanted to, you could even jump out and jump back in if you. If you caught any of that there, Corp, you can respond. I'm just kidding.
I don't know what he's getting at here, other than a plant matter being brought off the continents in association with where you'd be seeing stuff in the continental shelf.
He'll have to jump out real quick. Or Neph, if you want to like mute yourself and then unmute and see, because your audio has gone crazy. That being said, too, my timer just hit the hour mark for the discussion. How much longer do you guys want for discussion before? Because we do have a few questions too that might take a little bit of time.
How long Neph wants to go on for? I mean, I'm a night owl. It doesn't matter to me.
I think that makes all of us night owls.
Yeah,
Neph,
absolutely. Neph, are you muted?
If you're talking, I can't hear you. Nobody can.
The audio was going really good up till now, Neph. So I don't know if you something with your headset.
Maybe it's an internet connection deal.
Anyway, the point I was trying to make with the changes of sediment type that he's calling preposterous for some reason or another is that as environments change, so does the sediment that gets deposited in them. And I guess he's arguing that I have to believe that an inverted version of whatever's found there is found in the uplands. And that's not what I'm arguing, because the fossils are going to be unique to that area. And all that needs to be brought in are certain types of sediment from wherever's being eroded. I don't see what's ridiculous about that.
Nephi's saying in the chat he can't hear us either.
Yes, can you hear us?
Ooh.
Praise, I think you just hit puberty real quick or something, because your voice got really deep there.
Okay.
What the heck was that?
Yeah,
no idea, man.
I did not like that.
Oh,
right.
So
he's trying to come back again. That's
well, as he's trying to fix that. Did you want me to maybe just go over, because it looks like most of the questions
if somebody wants. Okay.
Yeah, most of them are. So why don't we save them all to the side? So why don't we throw a couple at you? Let's see here. Question from Sal for you, Corp. I have a question on folded rock. What temperature did they supposedly fold, and do they contain fossils? If at high temperatures, the fossils will cook.
It would depend on the exact rock, because there are different gradients of metamorphism. I wouldn't know which specific temperature is needed for which specific rock. What I do know is that there are actually, Sal, plenty of examples of fossils which have been deformed by that very process.
Okay, I'm
and
back.
In fact, if you look at the Roraima pollen paradox that some creationists talk about, there is actually evidence of metamorphic cooking of such pollen spores, or at least there's claimed to be. So we know that. I don't know how true that holds up, but we know that some fossils do actually show the evidence of being bent, formed, and deformed by these tectonic movements.
Well,
I don't know if that answers this question.
I
Nephi,
appreciate.
you're here. We're glad to have you. Sorry, I interrupted you standing.
Yeah,
And
I had an audio issue. It was just cutting out real bad.
Yeah, no worries.
Happening, so I had to come back.
no large. Or would you guys like to continue discussion or continue with Q&A? It's completely up to you. I'm
Q&A if you want. Well, for whatever.
Well, is there anything else from Corp, from your perspective, or Nephi, from yours, that from one another's presentations that you would like to address or at least bring up?
Well, unfortunately, I would like to talk about Surprise Canyon more because I just don't see what's so hard to understand about how you can't compare an incised valley to a modern river, because the river was isolated to the bottom at a valley, and that's why Caldwell's comparison is not appropriate.
Well, I've given a couple of reasons. One, the fossils we find in it are inconsistent with rivers.
How?
Well, because they're inconsistent with rivers.
How are they inconsistent with rivers?
Because most of them are marine creatures that live in the ocean.
At the bottom? No.
Those are not creatures.
Have you read the text on this?
Those creatures are not commonly found in
what they find at the bottom levels are very specific types of freshwater conodonts, and they also find and freshwater corals, yes. But most of the corals, which are marine, and there is a way to tell the difference, are isolated to the upper parts. The whole channel, Phil, Neff, and I don't know if you understand this, nobody's proposing that was all filled in by a river. Here's how the events went down as far as the literature is concerned. You have the valleys incised by rivers, and the bottom is a river-derived conglomerate. Then, as the land subsided, marine water started flooding in from the ocean, which turned it into an estuary. So now you don't have river action happening anymore. You have a very gentle estuary environment, and you see that's where sharks and other marine creatures, marine vertebrates, start to show up. And then as you get to the very top, it goes from estuary silts and sandstones to limestone, indicating at that point the whole thing had been submerged. So nobody's saying the whole thing was filled in by a river, and that's just not, nobody's ever proposed.
No, it's allegedly carved by one. It sounds to me like something created by the flood, especially since it has marine fossils in it, and it cuts through countless continuous strata that we know were laid down during the flood because they have fine, distinct boundaries.
So how do you, if you want to talk about the distinct boundaries, one, I feel like part of what confused me was you were asking me to highlight the distinct boundary between the actual channel and the sediment that filled it in. And I don't see what's hard to conceive of the bound, because I'm thinking specifically about your picture where you show how uniformitarianism allegedly predicts it would all blend together in one. And the point I wanted to make was, if the red wall was solid rock, and now you've got some river at the bottom starting to leave sandstone and conglomerate, why would they blend together if one of them's already lithified? And then as the whole thing lithifies, because it had to be solid when it filled those cave-in features, because it has no evidence of soft sediment deformation, should I expect that to mix too? And not have distinct boundaries between the sandstone and the clasts?
The best explanation is something that took place immediately after the Noahic flood, and not during, because that's why it carved through the strata. The reason it was able to carve through the strata is it was soft and moist, still recently deposited by the flood.
Okay, so
they have
you now think
marine
that the
fossils
Surprise
in
Canyon,
them, like corals and sharks, which are creatures that live in the ocean, and that fits the Noahic
and in
flood.
estuaries. I mean, you have sharks and other fish and things that can tolerate both salt and fresh water. But that's besides the point. Are you now saying that it went from being an intrusion to being a sort of post-flood feature?
Well, an intrusion is any material that passes through a contiguous.
Okay, I guess I could see how a channel could, in some loose sense, count as a intrusion. Yeah. Okay, that I understand that. But the problem is, Neff, that's in what's known as carboniferous strata, which means now if this is a post-flood feature,
that's just your uniformitarian.
It's buried. Well, I'm applying that to a geologic column in general. Not saying the dates, I'm just saying like that's what we typically ascribe it to. And in the middle of a Noah's flood, you now have all the overlying Supai group, the Hermit Shale, the Coconino Sandstone, everything else, and then all the stuff that's in the Grand Staircase that's been removed from that area. the Chinle Formation and Navajo Sandstone and all of that. You have such thick masses of strata to explain if this buried channel fill is a post-flood feature, because how are you getting all the sediment that had to be on top of it after in a post-flood situation?
Well, because there was countless local floods that took place after the flood of Noah. There were thousands upon thousands, maybe millions,
Okay.
and some of them were massive, which is the reason we have the Grand Canyon to begin with. So,
okay.
But here's just
well,
what's
I will make you
the strata. The material was deposited. The material was deposited by water. It contains sharks. It contains oceanic creatures, marine life, including coral.
In the middle and upper layers, and freshwater marine creatures.
Sounds to me like it happened underwater.
In the base. No, because that wouldn't explain why you have plant fossils, trees that are found, the root system.
The flood would.
At the bottom, and conveniently associated with a conglomerate and sandstone that looks like what we see rivers leaving today, with cut and fill structures that we see rivers leaving today.
The flood would certainly do that. It would mix plants and animals together.
Sure, it would mix them, but why didn't we? But if the flood brought these plants in, first of all, why are they found in what looks to be a fluvial environment and not, say, some weird out of place deep water dolomite?
Because you're a uniformitarianist and that's what you believe.
Wow, okay.
The simple fact is it was caused by water. It has marine life in it. It has coral in it. And I'm
not disagreeing. I'm not. Okay, but the fact that you have to have a sequence of events happen here, something you don't want to, I don't know if you're okay with it being some sort of river post-flood or what, but water has to carve this paleo valley, and you have to have 3 distinct units where for some reason plants only get associated with the lowest layers that look like a river conglomerate. And that's also where we only find like terrestrial vertebrate teeth. They're not found throughout the deeper stuff.
Are you familiar with Bryce's Canyon? You know about the debacle of uniformitarianism in Bryce's Canyon, don't you?
I have not heard this, no.
Okay.
But I don't see how it's relevant to this particular formation.
Here's how it's relevant. Because in Montana, there was a natural dam comprised of
was this caused by the Methuselah flood?
And glacial ice, and broke its natural dam and came scoring across the state of Washington, moving 500-ton boulders all the way across the state of Washington and dumping them into the ocean. And uniformitarianists denied that it was caused by a cataclysmic event for decades.
Oh, that was part of what changed uniformitarianism to actualism.
And so I'm just pointing out that if an aftermath event can bring that to bear on the state of Washington, create Bryce's can create the scablands of Washington state, and then it's not a problem for the flood of Noah to explain what you're describing. But what you
the thing is, it kind of is if no other creationist accepts this to be a post-flood feature, and I'm sorry, but I hate to briefly change subjects, but that buried landscape that I showed, that's in Eocene sediments, which creationists like Michael Ord and Taz Walker, and who's the other guy? Tim Clary, they think that's all flood sediment because there's too much of it, in their view, to be deposited post-flood. And they've done the numbers on that, and they know that you can't get those thick masses of sediment in only 4,000 years.
Well, if you listen carefully, in the early part of this discussion, I stated that I believed it was an intrusive event and happened during the flood. I'm not saying it was afterward. I'm just pointing out pointing out the cataclysmic events can explain these things, and the fact that it possesses marine fossils and corals and creatures not commonly known to rivers, you're having to violate. Let me finish, please. You're having to violate Occam's razor by adding complex explanations to it to say, well, the first part of it was formed this way, and then the later parts experienced that, and then the later part it got that. I don't have to do any of that. All I have to say is there was an intrusive event that took place during the flood of Noah.
Instead, that's not an explanation, though, because how does that intrusive event explain the lithification of the red wall, because you don't get 30-foot blocks bigger than a car from soft, goopy mud. It just doesn't happen. It has to be lithified, and Michael Ort has conceded that point. He's trying. Michael Ort.
That's not a problem for me.
So you think the red wall rapidly lithified, and then something intrusive carved it.
Let me put it this way: the entire geologic column rapidly formed.
So, but if you just argue that the Grand Canyon was carved out when everything was still soft, but before then the layer within the Grand Canyon had to be solid stone, how does that jive? Either the whole thing was lithified before the flood was over in order to explain the evidence of lithification, and so whatever carved the Grand Canyon afterwards had to be cutting through solid rock, not soft sediment, or it was all soft sediment at the time of the Grand Canyon being carved, meaning you don't really have an explanation for the evidence of lithification.
Well, as I've explained, I believe it was an intrusive event that took place near the end of at the end of the Noahic flood, and I find the fact that it doesn't fit a river. It doesn't fit the rivers as we know them. Possesses creatures that are marine.
It actually does fit rivers on a harsh surface, but the thing is that
was formed. It was formed by water. Okay.
Yeah.
That's what the whole geologic column was formed. All right. So it was formed by water. All right. Now you have to believe that it took millions of years to form, but you might want to explain how you got fossils in there, and each one of them being buried rapidly. And yet the whole process formed over millions of years.
Well, most of the fossils that are in Surprise
See, what you've got to do is make an exception for every fossil in it. That's what you have to
make an exception for everyone, or can I explain what the fossils are?
You do know that a fossil
not all fossils.
You do know that a fossil. You do know that any organism fossil is something that had to have been buried rapidly, right?
In what context? Like instantaneously? Because conodont shells are very tiny, and they can be rapidly buried because of their small size.
Comes the exceptions again. Look, I'll just say it like
make
this.
exceptions for the specific example of the
every geologist in the world acknowledges that an organism will not become a fossil unless it's buried rapidly.
Unless it's buried rapidly, yes.
That's correct. Right. All right. So all the fossils we find in this formation were buried rapidly. All right. So,
no, not necessarily.
Okay, there you have it.
What it is, they were buried rapidly in relative terms, yes. But it's not like the whole thing was one big dump event.
They had to have been buried in less than a month. They had to be buried in less than a month. They had to be buried.
Surprise me with a river that's buried, what's filling with sediment. I mean, that's not surprising.
They likely had to be buried in less than a day.
In fact, they actually document evidence because that's not surprising, because if you actually read the texts on this formation, what they note is that there are periodic intervals throughout where thicker bands of fossils are found that indicate storm-like conditions, because as this thing was filling in with an estuary, the ocean storm surge, that kind of thing, and that would lay down a significant amount of sediment. So yeah, there is evidence of rapid burial in the formation, but it's not consistent with singular depositional event.
Okay, so every fossil in it was buried rapidly, or you wouldn't have a fossil, and yet the whole formation took millions of years. I'm going to just say, on its face value, that's a problem. Now you can believe that, well, this part of it formed at this time, and then there was 1,000 years later or 10,000 years later that part formed. So you have to break it up within your theory. See, right? I don't need to do that. I don't need to violate Occam's razor by adding explanation upon explanation. It formed rapidly.
You violate Occam's razor because you're not actually explaining the evidence.
That's why it has fossils in it, and most of which are oceanic creatures, not living in rivers or on the land.
No, there are fluvial
like sharks
animals
and
at the bottom. Yeah, there are freshwater sharks.
Okay, they live in the ocean.
Have you not heard of bull sharks, for one? We know that there are sharks that can live and tolerate fresh water.
It's an oceanic creature, and so is coral. and so are most brachiopods.
There are freshwater corals too.
So are
No,
starfish.
not all brachiopods either.
And starfish, they're oceanic creatures, okay? And they're in this formation, all right?
They're not all exclusively
Each one of them had to
I
be
don't know what to
buried
tell
rapidly.
you.
Each one of them had to be buried rapidly. Everywhere going up through this formation where you find a fossil, it was buried rapidly. It had to be buried very rapidly. It couldn't have taken weeks because you wouldn't have a fossil. It's going to decay. Scavengers are going to eat it. Look, I'm telling you what. You
know
throw
the
a
majority
fish,
of the fossils are small conodonts, right? They're not like things that things eat.
you throw
They're
a
tiny little
fish.
conodonts.
If you throw a fish on the ground in the woods, around anywhere in the desert, and come back a week later,
That's not what we're doing, though.
there won't be a fish.
The vast majority of the fossils that are found in there are tiny, tiny, microscopic, microfossils, shark's teeth,
Flood,
or broken pieces of coral.
coral, broken,
Yes.
damage events,
Yes.
violence.
There are violent events that happen in nature. Storm
Right.
surges
See-
are one example. I live in Florida. I've experienced storms.
The flood model explains it fine, if you ask me, because each of the fossils going up through
No,
it.
it really
Let
doesn't.
me finish the
though,
statement
because they're
instead of
distinct
instead of us talking over each other. I understand you're excited because
Okay.
challenged.
Okay.
but
Go
you
ahead.
believe in challenge. Okay, but this is the simple facts. You have the last word on it if you want to. This is the simple observation I make. Fossils are found in it from the top to bottom. Each one of them had to have been buried rapidly. This indicates all of the materials there was deposited rapidly. You're happy to break it up into lots of little minor cataclysmic events that brought this material with creatures, and then later there was another one, and then a vast period of time landed another one. And you can believe that if you want. I don't need it. I don't need to explain it that way. The simple fact is, it's got fossils in it from bottom to top. Most of them are marine fossils, and that fits the flood model. Okay, you can have the last word.
Well, the reason I don't agree with you is simply because the red wall shows evidence of lithification, rapid, which doesn't fit most conventional flood models, which require the Grand Canyon strata to be soft prior to it being carved by a great dam breach, or whichever one you're going to go with. You're arguing that you have the most parsimonious explanation, yet you have gone back and forth between it's a mid-flood intrusion or, well, a post-flood
No, I didn't say
explanation.
mid-flood. No, don't misrepresent me. I did not say mid-flood intrusion. I said it was an intrusion, an intrusive event. It could have taken place at the end of the Noahic flood. It could have taken place right after the end of the Noahic flood. I don't know for certain. All I know is that the entire material was deposited rapidly.
And this is why I'm not.
Hold on, let me finish. I just know that
you said you let me have the last word. But
the entire material was deposited rapidly because it's proved by the fossils in it. So you attempted to misrepresent what I said by saying it was a mid-flood event. I did not say that.
I had misunderstood you. I did not mean to misrepresent you. I'm sorry if I did.
Okay. Continue with your last word if you want to.
Okay. The point is, just because something can be deposited rapidly doesn't mean that every bit of it was. And doesn't mean that it's a whole chaotic event either, especially with little microscopic fossils. It does not take very long to bury them, and not shark's teeth either, or fish scales, which are the majority of what's found. And that's not something that requires a giant like flash flood to bury them. Some lenses do show in situ corals, which were probably buried by some either storm surge or flash flood event. Other layers show just broken bits that look like they were probably broken off as the thing grew or as stuff pecked at it and fell off into the sediment. And because they're so small, it does not take long, even under normal estuary conditions, to bury them. Estuaries, I don't know if you know this, but they fill up with sediment very fast. That is why today we have to constantly dredge them. They can completely fill themselves in 10, 15 years just because the rate of deposition is the rate of water flow is so slow, so the deposition is actually fairly quick, even under calm conditions.
So we're going to move to a
question and answer session? Yeah, go ahead.
Okay, awesome. Well, I guess since I asked the first one, Erica, you can ask the second one. Before we do that, I do want to thank the both debaters for a really engaging discussion. We had at some point like 85 in the chat, which for this channel is a record. So thanks, guys. You brought the numbers today. It was a lot of fun. But yeah, we can go into the Q&A. I'll throw it to Erica if she has. You want to ask the next question?
Yeah, absolutely. So you asked the first one by Sal, yes, standing on Folded Rock?
Yes, you're right.
Okay. So the second one that I have is from Faithful, Honest, and True. It was not directed at a particular debater, so either of you are free to answer it. It says, it wasn't erosion, it was the fact that the mud layer wasn't big enough to reach the Grand Canyon. How did it erode if the contact points are dead flat between the layers that are missing?
The mud layer wasn't thick enough.
I think you should ask the question again. I didn't really quite understand it. Please ask it again.
I think it's fairly context specific. I think it was asked kind of in the moment when things were going on. If I'm remembering correctly, I think this is having to do with the Surprise Canyon, I want to say. It says, I'll read it one more time and we'll see if we can't suss it out. It wasn't erosion, it was the fact that the mud layer wasn't big enough to reach the Grand Canyon. How did it erode if the contact points are dead flat between the layers that are missing?
Is he arguing that the channel that's there was just caused by a lack of deposition? Is that the argument I'm hearing? Because that's kind of how it's coming off.
I'm not sure that we can discern the answer to the question.
I don't know what's being asked.
It's buried in the debate somewhere.
I think that's fair enough. All right, Stanley, you want to take the next one? I believe it's from Praise.
Sure, it's from, let me see, so Faithful, Honest, and True. Next one was from Praise, you said?
Yes,
Maybe I got them mixed up here.
Unless I missed it, I believe I did.
Oh, yeah, here we go. Okay. Praise. Question is for Corp. Do you believe in any catastrophism?
Yes, I'm an actualist. I understand that natural catastrophes can and do occur. And that these catastrophes don't always have to be something that humans have ever directly observed. I have never seen the late heavy bombardment, but the geologic evidence indicates that a lot of catastrophic impact events did happen in early Earth history. So of course I accept.
I just want to point out to you, Corp, that I don't know of any creationist that believes uniformitarianism means that the uniformitarianist doesn't believe any catastrophic events took place. We understand that.
It's not just that. They also make the arguments that, for example, that a geologist is being completely inconsistent. You need to read Michael Ord's stuff then. Because
no, Michael Ord doesn't. I've listened to lectures by Michael Ord and countless other creationist scientists. He doesn't believe that uniformitarianism means that the uniformitarianist doesn't believe that any catastrophic events took place. No creationist believes that uniformitarianists believe that every process is slow, that they deny volcanoes happen, or landslides, or tsunamis, or local floods, or earthquakes.
Well, not just that, but what Ord and Reed say consistently is, for example, that what we require is that we have to have modern examples of something to use it to be consistent with uniformitarianism. That's what they say.
Did you just tell us that Michael Ord believes that uniformitarianism means that there were no cataclysmic events that took place?
No, that's not what I'm saying. Or of course, people like Ord.
You said read Ord when I said that. When I said uniformitarianists, creationists don't believe that uniformitarianists think that all geological processes throughout the history of the Earth, there were no cataclysmic events that took place. You said read Ord, which implies that Michael Ord believes that there weren't any, according to uniformitarianism. No, you weren't implying that, were you?
Generally,
because it sounded like it.
No. I'm sorry if it came off that way.
But yeah, sure did.
What I see Ord say a lot is that uniformitarianists tend to believe in relatively constant rates of processes, including things like volcanism. So, for example, to people like Ord, it would be inconsistent for a uniformitarianist to say that there was more volcanism in the past, because it's not following the Lyell's version of rates being constant over geologic time. And when I heard catastrophe, I was interpreting it in the context of things like Noah's flood, I guess you could say, like large-scale catastrophism that is inherently not tied to modern processes we see happening now. That's why I brought up Ord, because what Ord and Reed like to do is say that to be a consistent uniformitarian, you have to appeal only to processes that happen today. So if I appeal to a giant meteor impact of a special type of meteor that no one has ever seen, we've never observed that process, and I make a hypothesis with it, to them they think I'm being inconsistent.
No, they don't. You're misrepresenting. You're misrepresenting creation. I've studied them. I've been listening to their orators. They don't put forth what you're saying. No creationist scientist in this world says that they don't understand that the uniformitarianism doesn't include asteroid impacts, volcanoes, landslides, tsunamis, earthquakes, and volcanoes. I mean, and local floods, even some of them very great local floods. So you're misrepresenting creationists. That's preposterous. No, they don't believe that at all. I've never heard of a creationist that believes that, and certainly none of the dozens of creationist scientists I've listened to give talks.
There was an article on creation.com that I read not too long ago. It was by John K. Reed, where he explicitly said that actualism requires modern equivalents to exist in the present. That is a misrepresentation. That is what he said.
No,
if you don't believe it, that's your issue, but no, I've seen it for myself.
No, I think you're misrepresenting what he says, because as I said, I've listened to, you can't name a creationist scientist that I haven't listened to talk for 4 hours. You can't.
Okay.
And none of them believe what you're saying. None. I'm sorry. Next question, please. That's not true.
Okay.
You got that one there?
Yeah, I gotcha. All right, next question is from Lil YEC, who is asking Corp, how you might explain cold slabs near the crust.
Cold slabs near the crust, I don't understand the context of that. I'm assuming plate tectonics. Wait, I think this might be the claim that catastrophic plate tectonics requires subduction of such slabs from with the runaway subduction hypothesis. Well, I think cool slabs would be entirely consistent with regular plate tectonics and would be inconsistent with catastrophic plate tectonics, simply because John Baumgartner, who came up with that, has gone on record saying that the heat issue that is caused by rapid formation of the granite of the oceanic crust has to be solved by God's direct intervention. I have a verbatim quote from him where he's saying that things like hydrothermal circulation and conduction do not work to get rid of the heat, and that he believes God had to directly intervene to keep the crust cool during the whole catastrophic plate tectonic scenario. And maybe with the advent of a miracle, then catastrophic plate tectonics could predict cold slabs. But based on every natural process we know of how heat dissipates from rock, it would be very hot from that process if it was happening that fast. So I don't know. I guess that's it.
All right, cool. All right, standing next one. You got it from Guzman.
Awesome. Okay, I'll read this word for word. So Guzman, he's kind of got 2 parts to here to this question. So I'll read it word for word. He says the Howe Quarry contains over 40,000 fossils, including fossils from 2 large sauropods over 70 feet long. What kind of flood would lay enough sediments to cover them together? And then he says, to the point that skin impressions are preserved on the sauropods, which means it was completely covered because the scavengers would make short work of the skin. I think
before we respond to that, let me respond to the cold slabs. The difference in temperature of the crustal ocean crust slabs that have been forced down into the depths of the earth, to the outer core, or 3,000 degrees difference in temperature, up to 3,000 degrees difference in temperature. And I'm going to put it to you that if you tried to push a massive slab of stone down into the earth to the outer core at the rate your fingernails grow, it's going to be as hot as the material around it by now. So this verifies
that makes sense.
Was forced
that makes
into
sense.
it
I'll look
rapidly.
into it.
Dope.
Okay, so now the question was about dinosaur skin, fossilized dinosaur skin. Was that correct?
Yes, it was concerning two large sauropods that were fossilized, and they're each around 70 feet long, if I'm understanding this correctly. And the question was for Corp here, but obviously, Nephi, you can answer as well. And it asks what kind of flood would be large enough to cover both of them together. Evidently there are skin impressions in the fossil.
Both the sauropods?
Yes, that's what I'm picking up.
Local flash floods can cover an animal. I don't see what the issue is, because it's not. I don't think the sauropod would be standing. I don't know if it's been, unless they're arguing it's been claimed to be found standing upright, and so however tall that is.
No.
Okay. So if they're dead and they're lying on their side, and then a flash flood covers them, for instance, and we actually see evidence of this in the Morrison Formation, where the bones have been dried out for some time and have been eaten by bugs, and then a flash flood covers them. Yeah, that's not going to be terribly hard for a river flood to cause.
Okay, my response to that is you have to appeal to rivers and things like that for all the fossils, especially large creatures, even a catfish. To me, it's preposterous. Whales have been known to fall dead on the ocean floor, and scientists, oceanographers go into them, GPS the whale's body, photograph it, come back 6 months later, it's half gone. Come back a year later, no whale, nothing, not even bone. The ocean, the worms in the bottom of the sea ate even the bone. Nothing left, not a thing. So to believe that a multi-ton dinosaur falls dead and becomes buried rapidly in enough materials that it's going to be preserved so that it becomes a fossil indicates there is one heck of a lot of sedimentary material being moved across the earth. I mean a lot. And miles, square miles of it, in order to make a flood like that. So to believe, I think for uniformitarianists having to appeal to, well, there was a river flood here. Well, what about that one? Well, there's a river flood. What about that one? Well, there was a river flood. And something like that, you have to make an exception for everything. And to me, that demonstrates there's no validity to the belief system.
Not at all, because anything that wasn't in those specialized conditions wouldn't have survived. It's called a preservation bias. Like, I don't see what's so hard to understand about that. If the one that wasn't near, like who's like, I don't know, 4 miles away, who died from the same drought or famine or whatever, if he's not near where that river is going to dump its sediment, if it's not near the banks, he's just gonna rot away.
Well, they wouldn't have articulated fossil in 3D space. Are you familiar with the fighting dinosaurs fossil? It's a velociraptor fighting with a I've forgotten the name of the species, and they're engaged in a fight. The velociraptor has its clawing at the head of the other one, the creature, and that creature has the velociraptor's hand in its mouth. They were frozen by sediments into space so rapidly they didn't have a chance to move. They were just, and there they are, dead, buried alive. Okay, couldn't move in thick sediments, and they're articulated in 3D space. And we find lots of fossils like that, T-Rex, Allosaurus, creatures where their rib cage, the shape of it is preserved.
The majority of fossils that are actually found aren't like that?
I find it, that's true, most are not. But there are plenty that have been. And I find even the thickness of the bone, of a dinosaur bone, could be 6 inches to a foot thick, right?
Okay.
Or more. To have that buried slowly, it can't be buried slowly. The whole creature had to be buried rapidly. But I think people like yourself, right? So, and that's throughout the geologic column. And you've got to make
along with smaller bits that show no, not for everything, because the vast majority of fossils that you find are like disarticulated pieces of joints that aren't found with the rest, and a lot of them, a heck of a lot of them, show evidence of being scavenged before they were buried. So they weren't just flash frozen in time. For the vast majority of them, they at least experienced some exposure and some scavenging before they happened to get lucky enough to be buried by something that deposits sediment relatively quickly. And not all of them are huge.
Yeah,
they're not.
You're doing what your kind always does. Everything is an exception.
My kind.
But the vast majority of fossils don't show scavenging. That's all.
No, they do.
No. What?
Yes.
The vast majority of fossils.
Actual
show scavenging?
paleontologists can tell you that the vast majority of fossils,
Okay, you heard it here,
very
folks.
small bits,
The vast majority of fossils show scavenging.
I should correct that to terrestrial fossils. Okay, because we're talking about dinosaurs here. Obviously, that doesn't include little microfossils.
You heard it here.
But yes.
I don't need to say anything more.
Okie dokie. Next question. Is this one me standing? Yeah, I think so. You asked the Starmod one, yes?
Yes. Yeah, this one will be yours.
Okay, cool. Not sure how easy this question is going to be to answer off the top of your head, but JJ wants to know what the volume of the water deposited sediment layers is around the world.
How much water created the geologic column? Is that what he's asking?
The exact question says the volume of the water deposited sediment layers is for the entire globe. That's what it says.
Creationists believe there's approximately half the amount of water that's in the oceans today was inside the earth. And it is that water which came out of the earth, which flooded the earth. So it was a tremendous amount of flood water. The flood didn't happen instantaneously. The flood covered, let's say, North America over a period of days, probably, before it covered the entire continent. Because one area, low-lying area, fills with water, and then it breaks its natural dam as the water gets higher, and it comes rushing over a hillside into a very large area and floods that one rapidly, and then it builds up, it meets a natural dam, and it builds up. And so it took probably days to a couple of weeks for the entire North American continent and other continents to be completely inundated by the flood. It didn't happen, bam, like that. It was a period of time that it took for the the waters to cover the continent, and then over a period of months, the constant moving of the waters back and forth, partly because of the action of the gravity of the moon, is what washed the materials backward and forth and created the sorting in the geologic column. That's the creationist explanation for the geologic column, in a nutshell.
All right, Corp, you got an answer for that?
Can you restate the question, please?
I sure can. Let me scroll back up to it. All right. JJ says, I want to know the volume of the water-deposited sediment layers around the world. Like what the volume of the entire volume, I'm assuming, of the water-deposited sediment layers.
I would just have to say that it varies on location, depending on how much has been preserved there. I wouldn't know if there's what the global average is.
Gotcha, roger that. All right, Standing, you're next.
Awesome. Okay, another question from Jungle Jargon. I'm guessing this is for Corp here. JJ asks, another question would be, how can there be 400 million years between water-deposited sediment layers when 50 million years would have washed all of the sediment layer into the oceans at today's rates? Take your time.
Because erosion doesn't happen at the same rate across the continent, and not everyone on the continent experiences erosion at one time. What happens is what actually happens in the real world is you'll have certain areas that are highly uplifted, and that's what experiences the most erosion. The erosion high in the mountains is significantly stronger than what's down in the lowlands. And so what'll happen is, as those come down and the erosion rate slows down, that sediment has to go somewhere. And it's not all dumped deep into the ocean. Most of the time it ends up on continental shelves or in river deltas and river floodplains. And what happens as plates move around, if one of those areas where the sediment has been ends up getting uplifted, now that becomes what's getting eroded. But it's still on the continent and it gets carried somewhere else. So what you wouldn't expect the entire geologic column, the entire continent to get completely eroded down to the ocean, but you would expect most places to have a fairly patchy record due to this altering deposition or this altering sequence of deposition and erosion when a place is a basin and then the times when it's not. And that's what you see.
My response to that is that the erosion rate is vastly too high for uniformitarianism to be true. For example, 367 miles of the coast of Texas erodes on an average 4.1 feet per year. 280 billion tons of continental material erode from the continents into the oceans every year. At that rate, in 20 million years, there would be no continents at all. So uniformitarianism cannot be true. In many places around the world, such as in California, 80,000 acres of coastal wetlands are gone every year. That's the size of 7 football fields disappearing every day. Now, you cannot have this kind of, in the coast of England, between 22 and 32 centimeters along the coast of Sussex disappears every single year. 22 centimeters times 1,000 miles of their coastland, a million years at 136 miles, that's 218 kilometers of material disappear. I mean, uniformitarianism is absolutely nonsense. The rate of erosion cannot have gone. The Earth would have had to have had virtually no erosion for almost the history of the planet for uniformitarianism to be true.
You have different parts uplifted where you get sediment from the continents, like brought down onto the continental shelf, and then you got things like in India where that same sediment that was now on the continental shelf gets uplifted into mountains and it's back on the continents. You have that cycle happening, and there will always be something on the continents. And you would expect a patchy record. Tectonic action.
What's dumping it on the continents so that it can keep eroding and not disappear?
What's dumping it on the continents?
Yeah, where's the deposition? The continents aren't
Rivers
rising.
Bring stuff down onto the lower areas of the continent.
Right, they take it from the continent to the sea.
And they don't drop it all at the sea.
280 billion tons are moving from the land into the oceans every single year.
Lots of stuff gets taken to the oceans. I understand that. But as a river moves, if you actually understand how the hydrology of river erosion works, heavier stuff gets deposited further inland and doesn't get brought to the sea at all. And it builds
I'm just
up
talking about
places.
the big picture. The big picture is 280 million tons of continental material is dumped in the ocean because of erosion by rivers and rain and snow and wind and sleet and hail, and every single year.
And lots of it either ends up being on the continental shelf and then turning back into continental mountains.
I'm talking about goes into the ocean every year, 280 million tons.
Yeah, on the continental shelf. That's where the vast majority of sediment gets deposited.
That's right.
The deep ocean basins aren't being constantly filled up.
The continents are getting smaller around their coastlines, not bigger.
Have you not heard of shoreline progression, where it goes out?
I just shared with you 3 places on the Earth which are disappearing at an alarming rate. And
how many places are building out? Because you see deltas all the time building out.
It's happening everywhere along all the continents. So here we are.
It's not happening everywhere.
Well, here we are, you in denial of science again. But
no, you're the one who's denying that there are many places where stuff actually builds out into the ocean. I'm sorry, dude.
The only landmass that's being added to the continents is in places like Hawaii when a volcano erupts and creates a couple hundred square yards of lava. Otherwise, the continents are not growing.
Have you never heard that deltas of rivers move out and they build on the actual shoreline? This is something that people who build houses have to account for. Not just that sediment will get eroded, but that stuff can get moved forward. They can prograde out into the water, especially if sea level drops a little bit. And then that's what
sea level is rising globally. It's not getting.
And it has fallen in the past.
Well, that's your belief. But what we know is the rate of erosion that we experience everywhere around the coasts of the continents cannot have been going on for millions of years. There would be no continents.
Sure it could.
Okay, guys, I've got
an actual idea of how deposition works. And where it ends up and how mountains bring stuff back up to the top.
It's going into the oceans.
And it gets uplifted again. Where it has to be
I'm going to jump in here real quick. That was the last question, but we did just get a super chat that came in real quick from Jamie Russell. Thanks for the super chat there, Jamie. I'll read it. I think the question is for you, Corp. He asked, how do you deal with slowest erosion rates measured on Earth, destroying the continents hundreds of times over? Uplift and erosion should have left no trace of fossils. And if it's uneven, why flat layers? Take your time.
Uplifted. Okay. So the first part, why are there continents at all? Because not all of it ends up in the ocean and just stays there. The stuff that builds up on the continental shelves gets picked up and pushed up by mountain ranges again and other forms of uplift. And that gets, and because the shoreline changes, the shoreline isn't static. Now that gets deposited elsewhere, and basically stuff builds up on the continents in some areas, erodes in others. In some areas where it's brought to the continental shelf, mountains will push it up. It's a dynamic sequence, and it's not just a constant erosion rate across the whole landmass. As for the flat layers, if you actually look at the geologic literature, things like paleo valleys, buried landscapes, river channels, hills, all sorts of buried topography, drainage systems are everywhere. Most of the time they have to be found with 3D scanning, but they do exist in a large abundance all throughout the geologic column. And if you look at oil industry logs and how they scan things, you can see it. So they're not flat everywhere. There are some places where they're flat, but that is, I'm sorry, I know Neff thinks that they are everywhere too, but I've looked at the literature, I've seen the pictures. There are tons of places where the strata is uneven and wavy and has clear evidences of being scouted.
Making those exceptions again, point to the rare exception. My response
to that
rare,
question but you don't have
well, they are. Every geologist in the world knows they're rare. You seem to not.
The geologists I've talked to?
No, they do.
They don't. Oh,
you haven't spoken to any such geologist. You bring him in here and we'll find out. I dare you.
Oh.
I dare you.
Okay.
Bring a geologist in here who will say the majority of the strata in the geologic column are not flattish. Okay. And
anything will be flat on a large enough scale.
Okay. Right. Just bring him in here. We'll see. Because I'm just going to call BS on what you said. Now, my response, because no geologist believes that. My response to that is that the mountains of the earth are not all rising around the world. This is a myth. Okay, many of them are actually going down. That's because they're finding their nature. A mountain exists on the top of the earth, also has a bottom, just like an iceberg does under the ocean. It has a root. Mountains have roots, and after the end of the flood, the mountains have been bobbing up and down, and now they're coming to a rest, and which means they're going to end up lower than they were at one point, at least in the past. The highest mountain on the earth depends on what day of the week and what week of the year and what year it is. Mount Everest is not always the highest mountain on the earth, because sometimes it goes down a little and sometimes it rises. Other mountains that are very close to it in height are coming up and they're going back down. This kind of geology, this up and down movement, is explained as an aftermath effect of the flood of Noah, but it can't be explained by uniformitarianism. They should have established their buoyancy in the crust of the earth millions of years ago. If they're millions and millions of years old, the fact that they're still bobbing in the crust of the earth demonstrates the flood of Noah.
Okay, unless you wanted a quick response, Corp.
I don't.
Okay, something that I did. So since we definitely discussed a lot of things during this discussion, like I said, it was really good. Audience had a blast. I had a blast, but the discussion kind of ended abruptly. Before we call it a night, did you guys each want just maybe 2 minutes to kind of sum up your thoughts, maybe tie up any loose ends? But that's up to you guys. Is that something you'd like? Just a 2-minute kind of wrap up?
You want to? It's up to you. It's up to you now.
It doesn't matter. If you want to, we can. Corp, it's up to you. If you want to do it or not, I don't care.
Well, why don't we do this?
I need it.
Okay.
Okay. If you want to,
no, I just, it was up to you guys. Just a thought. But yeah, unless I want to thank Erica for being the co-moderator here. Thanks for all the really good questions and the super chats. Like I said, I mean, we had it up to like 85 people or something. So it was really, really fun. If you guys want to give some closing thoughts as to plug in your channels, or I know there's an after show after this, I think on Dapper Dino's channel, if you want to touch on that, Erica.
Yeah.
Or you guys give the final few thoughts and we'll shut her down.
Who wants to go first? Corp, you or Nephi? Who wants to give their last thoughts first?
He can go first.
Okay, well, I would just say there are countless evidences of the flood of Noah and that uniformitarianism is false. The rate at which the continental plates, the continents erode into the oceans, not just from the landmass, but from around the coastlines, demonstrates that process can't have been going on at that rate for millions of years, lest there would be no continents. The earth would be a ball of water. The strata of the Earth are predominantly flat with fine distinct boundaries between them and possess particle size distribution. This is reproduced in the laboratory countless times. We know how strata form with observable, testable, repeatable science, and the entire geologic column was created that way. It's the only way you could have these features of the strata going deep into the Earth, because the strata form in groups. The strata below forms at the same time as the one above it and the one above that. They form together in groups, not one strata formed, then another strata, then another strata. This is reproduced in the laboratory and proven with hydrology. Strata form in groups. You'll have several strata forming at once, then another a slew of water coming with more materials creates another group and another group and another group. It means there's no geologic time in between them. Uniformitarianism can't explain the features of the geologic column. It's impossible for any of those strata to have either been the surface of the Earth or the ocean floor for a vast period of time, because there's no gradation between the strata.
Can I ask you one question? I'm sorry if this is too late.
It is, and to sum up, I'll say there's the list of features of the Earth that demonstrate the flood of Noah is outrageous, and I wouldn't. For me to give an explanation of all of them, it would take hours and hours of just nobody talking but me, and so I'll just leave it at that.
Well, okay. I guess all I really have to say is that for every proposed flood evidence that I've ever encountered, it has always invariably ended up not accurately representing what happens in nature and what uniformitarians actually propose. And I would encourage people to do their research, read the technical literature, make sure the claims are what they're claiming they are. Because for as much as he wants to go on saying that no, all the strata are like this, I know of too many examples where they're not, to find that credible, and certainly to find that as an explanation for everything that we see in the geologic record. And I would like to leave one more thought. If all these so-called problems were genuine, it would be very weird for this entire idea to be false, and yet it still succeeds in predicting the locations of fossil fuel and minerals and ore deposits, which it does. I'm sorry, Nev, I don't know how much you know about actually what the oil industry does use. Sure, you don't need to use these methods that require an understanding the depositional environment and the geologic history of the region, but that is the most effective way to gather it, and that is what they use. And if you don't believe me, I mean, you're welcome not to, but reading their text would actually say otherwise. So all I have to say is that it would be weird for their predictive power to be so precise if the entire idea is wrong and everything they're based on is wrong. That's all I have.
Okay. Well, thank you for that, Corp. Go ahead, Erica.
Oh no, I had a ball. I had an amazing time listening to both of you kind of banter back and forth. I hope everyone else out there had a good time too. I kept an eye on the chat. It seemed like people were very, very engaged. Everyone loved it. You know, that's all I can say. I think it was certainly a success as far as, you know, people out there getting something out of the conversation, which is really all we can ever ask for.
Exactly right. I couldn't agree more. I think it was a really profitable and respectful discussion. So thanks for keeping it fun, guys. Praise, unless you got some final words, my man, you can shut her down anytime.
Great job, guys.